presentation, and then we can have 10 minutes of discussion.
Perfect. Can you see the screen?
Yes.
Okay, perfect. So this one is the first presentation of the day, and just a first presentation. For who doesn't know me, I'm Matteo Mazzarano. I'm currently a PhD student at the University of Ferrara, but I've started the postdoc a little earlier, and I'm doing it in the Catholic University of Milan. But I'm going to present, this is a chapter of my PhD thesis. And basically, to introduce the aspect of the research, it's just a way to scope, to study how much can we potentially recover from electrical equipment. And let's put it this way, in terms of importance of our daily life and policy making and so on, electrical equipment is the collection of commodities that are driven by electricity. So they are, of course, a force of digitalization, and they're probably one of the most important set of commodities of the industries in the 21st century. Second of all, they contain quite amount of precious minerals and critical raw materials, so they are vulnerable to, so the fact that they are so complicated, complex commodities, they are vulnerable to many stress, from trade to circular economy and so on. So they are sometimes they are difficult to treat. So in this sense, they are quite relevant for growth objectives, occupation and sustainable development. But in order to answer to these problems, European Union started the Raw Materials Initiative in 2008, and it is based on three main pillars. So responsible sourcing is the idea that you want to safeguard your trade routes against human rights violation and conflicts. You can see it right now in Congo. We are having quite problems with cobalt.
Matteo,
yes?
Sorry. I thought it was like a delay from the network, but I can still see your presentation. I see your screen, but not the PowerPoint, if you have one.
Wait, can't you see right now?
No.
No? Okay. Probably I will have to restart again.
Yes.
Interrompi presentazione. Porca miseria. Okay.
Sorry for that.
No, it's fine. It's fine.
No, just because I know that there is delay sometimes when you start to present, but it was not the case.
Sorry, Matteo. Maybe you have to share only the windows and not the entire desktop.
Okay. Could you see? Wait, what's happening?
Yes.
No. I think I'm having some issues here. Let's see. Can you see right now the desktop?
Yes.
Okay, so let's go on. Apparently some pages shut down. Okay.
Great.
So we were here, and yep. Can you see it?
Great. Yes,
fantastic.
That's perfect now.
Fantastic. So we were at responsible sourcing. So it is the safeguarding of your trade routes from conflicts and human rights violation. But we are mostly interested right now in the second pillar, so material recovery and secondary materials. But there are some definitions that we can take from mining. So, for instance, we want to recover some materials from waste, from especially this waste from this very relevant set of commodities. And so why do you want to do that? You want to do that because you want to recover rich elements, and you want to avoid to treat further on the supply chain environmental hazards. And you have a very complex set of policy issues, but I believe that there are, between 91 and 2017, we have the measure. So the Waste Framework Directive, which divided the main source of waste, and in particular, it contains also the definition of electrical waste, and then you have the specific one for the calculation of weight and so on. So this particular research was made to underline this particular objective. So how much can we potentially recover in terms of specific minerals and critical raw materials from this waste? And if I was interested to find out if this potential was constant over the time and if there was some sort of heterogeneity between the European nations. And what's the outcome of this study? Basically, I outlined the fact that there are some possible definition that you can take from mining and apply to secondary materials and circular economy. And secondly, it's a dataset that I used in the second paper that I will discuss today again. Are you still following me? Hello?
Yes.
Okay,
yes.
perfect.
Yes.
Thank you.
Yes.
It's okay.
Thank you. So this is a brief insight to the stock of electrical equipment, and I use the definitions from European Union. So you have one of the measure is temperature, then you have the weight category, large equipment, and just to give you an idea, these are fridges, temperature controls, and so on. But probably some of you are more interested in small IT and telecommunication, which is the purple one here. You see that these are three interesting nations. So one, it is stratum. This is one of the first tercile, Germany. Then you have Italy, second tercile of GDP, and then you have Romania. And you see that the composition changed quite drastically in 40 years of study. I thought this probably affected the potential recovery of materials. And just to understand which kind of critical raw materials are we talking about, we have 18 from the precious one. So we will see, for example, gold, silver, and so on. We also see some other rare like antimony and so on. And then also the standard like copper and so on. So we have 28 countries. It was the entire European Union, but then UK decided to separate itself, but it is still in our study. Between 1980 to 2020. It comes from, it's not mine, the data. I just took the accumulation data from project and the ProZoom project, and I used it for this. And just to give you an idea on how it is estimated the amount of in-use stock of electrical equipment, they used this inflow-driven methodology. So they basically assume that the entire stock is defined like an integral, an accumulation of net addition. And every net addition is based on internal production between one nation, imports of products, minus waste, and minus imports. So, but how waste is estimated, because it is not, you don't have necessarily all the time data about waste from electrical equipment. So you basically assume that every year net addition has to substitute, at least in part, the in-use stock. And so this is estimated via a cumulative function of Weibull. And this is basically the characteristic function. So you have two parameters and time. So basically you have to look at, when you buy a commodity, you will have to substitute it at a certain time. So the more time passes, the more it is probable that it will be substituted, until after let's say 10 years, according to the type of commodity, it will be spent. You cannot use it anymore. And this varies. Of course, you have several types of commodities. In here, we have more than 30, but fortunately, you can aggregate all in 6, as we have seen before. And in terms of methodology, it's quite intuitive, as you will see. So, what kind of potential could you think about? So there is waste, and then there is also in-use stock, because as you see, in-use stock after a certain time becomes automatically waste. So you can presume that what's right now in use right now will be in 10 years what we will have to recycle. And from mining, we can use the ore grade definition. So you can take the reserves, which are the reachable amount of resources that you can extract, and then there are the resources which comprise all the possible materials. And when you look at waste and circularity, you are probably looking at waste as a reserve potential. So it is I thought to call this artificial because it comes from man-made resources, reservoirs, let's say. And how do you calculate this potential? It is no matter how it is resources or reserves. You basically have to take the best available technology. So how much right now we can potentially recover from one commodity, and this varies for 18 materials and for each group of commodity. And then you have how much the stake, how much the commodity is represented within the stock, and then you basically make the sum of the interaction, and so that gives you basically how much you can potentially recover. It's not that's complicated. It's just a quite pain to extract all the data. If you divide these results according to nation and time, you see that results will quite vary. I use this tercile distribution, like first stratum. It's for the richest country, which are mainly northerners one. Then you have the southern ones, which comprise mostly the second tercile, and then you have the third one, which is basically represents the eastern ones, so the newest to come to European Union. And this is the stock. I don't know if can you see it a little better?
We can see all the graphs. It's small, but we can see all the graphs.
Okay, so you can see that it is not even remotely constant, and it varies greatly across strata. So, for example, in most cases, rich countries, which are the red line, are the one that find it easier, and at least this is the potential. The potentiality is way higher in northern countries, probably because they acquire better equipment on average, and better equipment usually comprises richer resources like gold, like silver. Where is it? Argent. Eccola qua. Then this is stibum. This is antimony, which is relatively richer in second strata, but you see that on average it is way easier to extract resources, circular resources in richer countries, which is quite a problem if you want to consider divergence in environmental performances. And this is somewhat structural, so it's not easy to recover in some legislations, let's say. This is the waste one, so it's right now how much you can potentially recover. And if you want to look at how can you read this kind of plots? So these are waste from commodities of 2020, wasted in 2020. And if you look backwards, these are commodities that are wasted, and probably they have to be wasting in 2000 or 2020. So you see that very old commodity is relatively richer in material, probably because it is it contains less plastics and more metals, for instance. But there are, on average, if you look at precious materials, while there is an overall reduction in potential, we are still quite over the parts per 10,000, which is, if you compare it with the natural ones, natural extraction of gold, it comes from part per millions, while in European Union, if you want to extract gold from electrical equipment, it is in part per 10,000. So it is way more richer. Of course, the amount of resources that you can potentially extract is way lower. But moving forward, in terms of weight, the total weight that you can reuse from electrical equipment, this is the artificial ore grade. You can take almost 20% in 2020, at least in richer countries. But you see that while you had some structural differences in the past, you are now having a slow convergence. I use the Shannon index plus just to say that Shannon index basically indicates how much it is diverse, the stock. And you see that it is becoming. It was relatively different in the past, but it is becoming way more similar because probably people are acquiring basically the same amount of electrical equipment like fridges, computers, and so on. So this is quite a good trend if you look at circular potential. Just to discuss a little the results that we gathered. In terms of potential repository, electrical equipment is very, very rich of critical raw materials, which is a very good aspect for conflict minerals if you look at it that way. So it means that you can easily drive away raw materials from international trade, especially cobalt and so on, from international trade. Or at least in our study, we studied, for example, antimony, which comes from, if I'm not wrong, United States and China, which is currently thinking about reintegrating trade policies against the WTO. So it's a very good result. And income affect accumulation in long term. So this is quite a problem if you look at that long-term potential. And I think that in terms of economic study, we should use probably time spans and other variables to study the accumulation patterns. And this is how much basically we studied. So the conclusion is that we have data to study this potential recovery. There are limits to circular potential, and probably it is somewhat economically predictable. And since this study came from a data set from industrial ecology, there are probably potential links in terms of studies in the future. And I hope it was relatively interesting for you. Thank you.
Thank you, Matteo, for this presentation. So I would like to open the floor to questions if there is someone that wants to ask something. Don't be shy. Okay, Susanna.
Yeah. Thank you, Matteo, for your presentation. That was very, very interesting indeed. But I didn't understand maybe the basis of this presentation. That is, are you talking about a potential accumulation, or is that, I mean, that can be different from real true accumulation? So is it the potential mining or it is the true mining? Because, you know, a lot depends on waste management policies and on how people are incentivized to recycle these potential commodities, or if it is if the policies are enough to collect this potential mining. Thank you, Matteo.
Okay.
Sorry, I didn't understand from just at the very beginning of your presentation.
Okay, no, thank you for the comment. Probably I have to address this better. It is basically the maximum potential, because I consider the best available technology, but not everyone has at the same time also in the past used the best available technology. So it's basically according to how much you have, how much you can potentially recover. You can put, so it's basically an estimation of how much you can potentially recover from this particular category of commodity. So that's basically the idea of the study.
Which is very interesting in any case, because the potential is very high.
Thank you.
Okay, anyone else? Okay. So can you hear me?
Yes, Mariana.
Okay, great.
Yeah.
Okay.
Mariana, sorry, I have raised my hand at late time. Sorry.
No, it's okay. It's just that for a moment I couldn't hear anything, and so I was like, Go ahead.
Thanks. Thank you, Matteo, for your presentation. It's really interesting, and from my point of view, because I'm working with my colleagues on waste and mines, but especially on rare earth, as you know. And I will ask you specifically if you because I don't see any of types of metals and waste that you have taken into account, silver, gold. There are also rare earth that could be divided, or you have to take lanthanides altogether?
No, I didn't consider the heavy rare earths because they're very difficult to find data about potential recycling.
I know.
And usually in terms of use, like they're very small.
Very close rate.
So that's a problem. But you have antimony, which is if I'm not wrong, light
rare earth. Okay.
So, but at least for European Union, that's a critical raw material. That's known for sure.
Okay, thanks.
Okay. So if anyone else want to ask something, it's the right time. If not, we can just go to the next presentation, which is from Chiara Lodi. So she's presenting a paper which title is An Optimal Strategy to Control Consumption and Recycling of a Non-Renewable Resource, an Application to Rare Earth Element,
Yes.
which she is working on together with Stefania Ragni and Silvia Bertarelli.
Yes, thank you, Marianna.
Also for you, you have around 20 minutes for your presentation, and then we will have 10 minutes for discussion.
Okay, thank you so much. Firstly, I will pass on the chat the famous link for a coffee break with me at the 4 p.m. if you want, as suggested by the organizer. So thanks.
Thank you, Chiara.
I share my screen.
Yeah.
Let me know if you see anything.
So the screen has arrived, and also the PowerPoint.
Okay, thank you. So maybe it's better that I switch off my camera in order to don't have here the connection. Okay. So thank you so much for the organization of the workshop. I really thank you, Jacopo, and all the CERCI staff members that made a hard work in order to organize all the event and for us to being here today. I'm Chiara. I'm a research fellow at the University of Urbino Carlo Bo, and I'm here today in order to present a very preliminary work that is going on with two colleagues from the University of Ferrara, who are Silvia Bertarelli and Stefania Ragni. Specifically, the work is an optimal strategy to control consumption and recycling of non-renewable resources, but we try to model the most relevant characteristics of rare earth elements, which is a very specific type of non-renewable resources. I will show you which is the main aim of our research, and very briefly I will explain you what is the rare earth scenario. What is the literature which are related to, and what is the contribution of our work. I try to be as simple as possible in order to present a very baseline optimal control model and the nature of solutions, so the first order condition for the optimality. And finally, we have tried to think about the future possible purposes after our work. But first of all, it is important to understand which is the general scenario in which we are allocated. We know that worldwide there is an increasing importance of environmental issues, especially in terms of circular economy. We are here in this day to focus on this aspect, and especially in terms of preservation of better management of natural resources, or the improvement in waste management technologies, but also in order to encouraging a secondary raw material market. In this scenario, the non-renewable resources management and market are especially affected by the circular economy and environmental policies dynamics, because this type of resource have special characteristics in terms of availability, of essentiality in the production. They are important in terms of sustainability sustainability, and also in terms of the fact that maybe recycling a virgin material is not a uniform quality. They don't have a common quality. Also in terms of develop technology, mining, extraction, waste disposal, recycling, and also in terms of market structure. All these characteristics are different for each types of non-renewables. So what is the aim of our research given this scenario? The aim is to develop an optimal strategy to maximize the social welfare function by controlling for the consumption, the employment, and the recycling of non-renewable resources in a finite time horizon. Specifically, we aim at constructing the model by considering the most relevant characteristics of rare earth element, as I explained you before. And we would like to integrate this optimal control model with a specific rare data in order to evaluate their consumption, recycling, and implementation in the production. So what is the rare earth element scenario? Non-renewable resources in general has a higher importance, but rare earth play a very important role in the economy today. The rare earth elements are a family of 17 periodic table elements that are called lanthanides, and they are basic on their atomic weight. They could be classified in light and heavy rare earth, and generally they are found in the earth crust as a compound. But this type of non-renewable resources play a crucial role from different point of view in terms of innovation, because they are highly implemented in high-tech and green technologies, but also in military sector. This is also important in terms of geopolitical aspect. But in geopolitical, from the geopolitical point of view, they are considered, especially in Europe, as a critical raw material, because the market dynamics in terms of demand and supply are highly uncertain and risky. And finally, but not the least, they have a higher importance in terms of environment. In terms of scarcity, we will see soon what we mean with scarcity. We know, as also Matteo said, that there is a high amount of waste from end-of-life product in which there are contents of rare earth element which could be extracted and separated from the other part, but also the mining process of the rare earth element and also the transforming activity is expensive and also generate radioactive waste material that could be managed in the best way possible. But maybe among these, the rare earth market is very interesting, because from one side we have the demand. So there is an increasing in demand, given the fact that there is a higher implementation in high-tech and green technologies. But on the other side, we will try to reduce the demand of rare earth, raw rare earth element, because in order to recycle them from the waste. Furthermore, there is also a balance problem between the demand of rare earth and the natural abundance of this in ores, which is relevant for the production. And on the other side, we have the supply. The supply is very risky and is strictly connected with China, because the main rare earth elements are located in China. So other countries highly depends in terms of raw material from rare earth element mining sector in China. You have to know that until the 2015, the China imposed an export quota on rare earth element. Today, this export quota doesn't exist, but Chinese government improve environmental aspect policies, try to control illegal mining of this type of non-renewable resources, and also try to boost the efficiency in toward this type of non-renewable. But this country remained the first exporter of rare earth elements in terms of raw material, even if other countries try to be more independent from China. As you could imagine, this market dynamics is very very tricky. We begin by asking ourselves if there are new space in this market. Ideally, yes, because we want to reduce the dependence from China. We would like to increase technology that could be useful in order to substitute the rare earth element with other resources. And we also try to increase recycling efficiency. Today, many joint ventures that could help in knowledge transfer toward this aspect are highly useful. And there is also a crucial role of technology and R&D. But the reality, what is? Only Japan has reduced its dependence from China. EU and South Korea are more independent in terms of compound, so in the composition of many rare earth, but not in terms of the raw material rare earth. From the US, remains the first producer, but it has reopened a rare earth element mine in California, and is trying to develop by itself a processing technology in order to be more independent. From the EU perspective, other than the more independence from the imported compounds, there are many projects that try to improve the recycling technology and the rare earth compound production toward the Green New Deal. And on the other side, there is research also in terms of finding depth acceptance of exploitable rare earth resources in Europe, especially located in Greenland and Nordic countries. Very briefly, what about mining and recycling of rare earth? Referring to mining, there is an abundant in earth crust, but difficult in accessibility. In this case, we are talking about scarcity. In this sense, this type of element are scarce. For many type of rare earth, it is uneconomically to mine because it is feasible only when there is enough output to regain investment cost, and minerals have high ore concentration. Reserves are specifically located in China. The process of mining is long and required higher investment, and there is a strong environmental impact on climate change, since due to radioactive element to dispose. Recycling is very important, but we have to know that small quantity of rare earth are obtained, but valuable long-term additional resource. We need a more efficient collection system, and we need to develop technology to be improved, because until now there is difficulty in separation process. But recycling has a lot of advantages, because it is less environmental damage than the mining. It could represent a new opportunity for job creation, and that could represent an increase in the supply, which help in alleviating the balance problem. The related literature review is mainly represented by 4 branches. One is the dynamic optimization model of non-renewable depletion. The second is the optimal control model, which includes recycling, the optimal control mathematical theory, and the literature on the rare earth elements in terms of state of art, recycling, balance problem, and also the connection between rare earth and the circular economy. Here are some suggestions if you want. What is our contribution to this existing literature? We construct an optimal control model by considering specific characteristics of rare earth, solved over a time finite horizon. This assumption is very important, because we have to think in terms of circular economy and environmental issue. It is a quite rather new approach, because the highest part of work are concentrated on an infinite horizon. We consider that the virgin resource, which represent the raw rare earth material, is important from a foreign country at a given price. So in our economy, try to think as Europe. We have only recycling, production of intermediate goods, and final goods. In future, we have to apply a numerical simulation with specific rare earth data. Very briefly, and try to be as simple as possible, what are the assumptions of our optimal control model? We have the production of a final good, which is produced by an intermediated good and capital. And we have an intermediated good, which is represented by virgin material, virgin resource, sorry, which is the rare earth, which is important at a price beta from another country, maybe China, and the recycling resource R, that is, we suppose for simplicity, is instantaneously extracted from a domestic urban landfill. So this means that waste production and dismantling occur instantaneously and at the same time. So R entails a unit production cost, which is constant and equal to tau, and expressed in 1 unit. The intermediate goods is considered as a product enabled, because the rare earth could be product or enable or non-product enable. In our case, is product enable because it is implemented in the final product in order to give it unique properties, okay? Furthermore, labor is completely devoted to recycling, and we have an initial endowment of capital K0 which is higher than 0, and the amount of virgin and recycled resource at time t is always 0 or equal or higher than 0. Our production function of intermediate goods and final goods are expressed through a constant elasticity of substitution function. Specifically, when we talk about the intermediate goods, the recycled material and the virgin material are imperfect substitutes. So the elasticity of substitution is higher than 1, while when we consider the production of the final goods, the intermediate goods and the capital are considered as complement. So the elasticity of substitution is within 0 and 1. Considering the consumption side, so in its instant utility, the consumption in T is always positive, and the utility is equal to C at the 1 minus sigma divided 1 minus sigma, where sigma is a parameter within 0 and 1. What about the waste generation and accumulation? We have to suppose that the waste is generated considering the fact that we have a waste rate generation both from the virgin and recycled material, which are denoted by the parameter gamma 1 and gamma 2, which are exogenous and constant and within 0 and 1. The waste flow is represented by this equation, gamma 1 multiplied by for V plus gamma 2 multiplied for R. We have a cumulative amount of waste at time t that is equal to W in T, an initial stock of waste that it is higher than 0, that is W0, and the waste accumulation is represented by the waste flow, but less the part that is recycled, because we suppose that it is removed from the accumulated stock of waste in that specific time t. Given this assumption, if we start by upper bounding our use of recycling material, we could make the 2 important remarks. The first remarks is that the maximum time t to which that allows us that the landfill is completed empty when the recycling is boosted to its maximum at each t, it's equal to W0 divided by 1 minus gamma 2 R maximum. And the second remarks said us that how many virgin material we can put in the landfill to fill it completely when the recycling is boosted at its maximum. So these are first important thing that we could think about in terms of time, in terms of what are the parameters that came into the game, especially the gamma 1 and gamma 2, which in some way capture the technological ability to produce, to reduce the waste, okay, from the production, from the implementation of the virgin material and the recycled material. This is the maximization problem, so that the social planner try to maximize the social welfare function by choosing consumption, the quantity of virgin material and the quantity of recycled material in T. This social welfare function is composed by the integral from 0 to T of the utility multiplied per E at the minus delta T in ddt, and two scrap functions that are considered because we consider a finite time horizon. The kappa scrap function is referred to the capital. It's an integral of future utility flow related to future capital. It is increasing in K, so this means that the future utility flow is higher as the kappa in the final T increases, while the scrap function related to the waste is an integral of the future utility flow related to future damage from the urban mine, and it is decreasing if it decreases if if W in T increases, so that the future utility flow is higher if W in T reduces. The constraints are the same that we have seen before, and the state variable are represented by the accumulation of waste and the accumulation of capital nearest the initial assumption on the urban mine and the capital. As you can see from the accumulation of capital, we have implemented the cost of imported good, which is minus beta V, and the cost of recycling, which is minus theta RT. We have conducted the first set of analysis. The current value of Hamiltonian is this one that you can see here, where the P and omega are the current value shadow prices of waste stock and capital stock respectively. And we have calculated the first order optimality condition. As you can see here, and by considering this result, we are not able to calculate in a closed form the analytical solution, so we have to approximate it in order to get numerical simulation. So the problem is more tricky than we have imagined at the beginning. It's also a very baseline model and a first impression that we have tried to model. So every suggestion and are welcome about how to better modeling, or what are your ideas about it. And finally, we have to think about what could be future research proposals that could born from this work. We could account maybe for the R&D investment in recycling sector, but also maybe in the mining and the management of environmental damages from the mining sector, so the waste disposal of radioactive materials. We have to know that we have to preserve non-renewable resources from one side, but rare earth elements are needed to develop green technology, which now is very boosted in our economies. But also, so we have to think about the substitutability of rare earth elements. Another approach could be the Dasgupta approach, so which is very new. We could introduce in the production function the aspect that we are inside on a biosphere, and finally maybe account for an imperfect competitive market regime, since China is a monopolistic, as a monopoly on rare earth, by analyzing the dynamics of decentralized economy. So that's all. Thank you so much for the attention. I hope to be on time, and I really like to thank for the attention.
Thank you very much, Chiara, for your presentation. So I will like to know if anyone has a question. So I can see Alessio and then Matteo.
Good morning.
Hello.
Hello.
Hi.
Can you hear me?
Yes.
Yes.
Okay. Thanks a lot. Very interesting. And rare earths are really a hot issue, I think. So there
Yes.
is really the need to do a lot more also in terms of theoretical research.
Yeah.
Okay, but I have a comment that is about the narrative of the paper, because at the moment what I see is that the way in which your model becomes specific of rare earth elements is that you will introduce a specific parameter values representing that market, because at the moment your model is a model where it's the land for land filling that is the non-renewable resource. Okay, but I mean this is interesting because I mean I don't know how far we are from the filling up all the landfills, but I think that this is not the biggest problem. Maybe what you could do to make the narrative more consistent with the idea of a rare earth is also to model uncertainty, in the sense that you may have an uncertain supply, which is exogenous. So you recycle more in order to cope with uncertainty. So uncertainty is a kind of insurance against shortage. From your face, I see that it is not, I mean, I realize it's not easy to introduce uncertainty in this kind of dynamic models, but from your motivation, the main point of rare earths under a net importing country point of view is basically what happens in exporters. So the monopolistic power is one fruitful extension. The use of specific parameter values is another one, but I would encourage you to try to model also uncertainty. I think that there are non-renewable sources model with uncertainty. I can look for them, but I think there is something already available. So I can, but anyway, thanks a lot because it's really challenging.
Yes, thank you so much, Alessio, for your question. We have think about it. As we know from, and as I said before, also this is one of the simplest model that we have, and we have already needed to do the numerical approximation. So it's very challenging. Until now, we have think that all it is captured by the beta value, which capture all the dynamics in the market of rare earth on demand and supply that capture the price. So what could change, because it's a simplification. It's very a simplification, but we have already talked about how we can manage these things that you have said to us. So it is a preliminary work, and we try to firstly to construct the baseline model, and then we get further. So thank you if you have some suggestion on literature on that.
Okay.
I also see Susanna and Matteo.
So now it's time. I think Susanna has her hand raised from before.
Yes, sorry.
But no problem. So now it's Matteo. You can go on with your question.
Okay. Thank you for the time. It's just a small comment. I think that we are, when you think about rare earths, there is we are not looking at the true potential extraction. I mean, in circular economy, we always try to find the resources from waste or avoiding waste and so on. But actually, there are some articles about rare earths and the sea floor. So I guess that we are, if we are interested in circular economy and biodiversity, there is always the end game of sea floor extraction. It means that basically people are starting to study how much you can extract in terms of methane, oil and gas, and rare resources from the sea floor. And if you are a biologist, I was interested in this because I had one of my, I know a person that works in defense, and he says, well, it's not that much problem because if we are having a problem in international trade, we are going to scrap the sea floor in search for for critical raw materials. So probably the end game is that you want to avoid doing that. So I guess that a very interesting insight would be like, there is also this alternative, but we want to address the fact that we want to avoid that, basically.
Yeah.
So that was just a small comment. Thank you. Thank you for
No,
your
thank
work.
you. Thanks.
Okay, thank you very much. So anyone else that would like to ask or just suggest something?
I think
Okay.
so.
No? Yeah. Okay, thank you very much, Chiara.
You're welcome.
Thank you for all your intervention. So now it's up to Alessio, who is presenting a paper whose title is Waste Recycling for Policy, Waste Recycling Policies for Circular Economy Transition, an EDSGE approach, together with Argentiero and Mariangela Zoli. So as for the other,
I don't know.
Tell me, Alessio.
Sorry, can you see the screen? My
Yes.
presentation? Okay.
Yes.
Great.
So you have around 20 minutes, and then we are leaving 10 minutes for discussion.
Okay. Thanks a lot to the very precise chair. Thanks a lot to the audience and to the organizers for this wonderful workshop and for this chance to present this paper. I'm afraid the title has changed slightly because when focusing on our paper with Amedeo and Mariangela, we thought that maybe one of the possible applications of our paper, of our model, was trying to understand possible implications on waste related to a very original topic, which is COVID-19. I think that everyone in any field has at the moment a paper on COVID-19, so why couldn't we? But anyway, apart from joking, as I hope it will be, I will be able to convince you that indeed our very abstract framework is anyway capable of allowing us to say something about possible short to medium term implications of the pandemics. But overall, what I would say is that our model is in general an attempt to go a little bit farther as compared to the existing literature in terms of the analysis of the impact of several different potential drivers on waste management decisions. So basically, the general motivation of the paper rests in the fact that, at least to our knowledge, most of the waste policy literature is analyzed either theoretically, mostly in partial equilibrium, or in very stylized general equilibrium models, which are very elegant and are very fruitful to provide the general results, but are not capable of understanding, for example, the dynamics and the short-term, let's say, shock-related impacts of different economic and non-economic variables on waste management. And also, there is a big empirical literature related to waste management that I will mention shortly, and that tries to analyze the drivers of waste-related behaviors and waste management, both in a micro and in a macro perspective. So what we would like to do is to use a DSGE approach in order to try to focus on the impact of shocks related to technology, shocks related to taste, and the shocks related to other facts like waste policy and also the COVID pandemic in the short, medium term. So what we will do, what we did in the paper was to develop a simplified model, a simplified DSG model that is capable of disentangling not recyclable from recyclable production and consumption, and to understand how we can drive this with policy and other economic factors. And the difference between the moment in which this paper was submitted to the workshop and today is that we also tried to develop our model and to apply it to the COVID-19 pandemic. And this was driven by the increasing evidence that indeed the pandemic is having a non-negligible impact on waste production and management. So it's very important that we try to understand better this phenomenon. Okay, in relation to the literature, and hoping that you are still there, because I only see my screen, I can say that we link mostly to three main strands of the literature in this paper. The first one is, as I was mentioning before, the literature on waste management and policy. And basically, just to give some examples, because I cannot go into details in the whole literature, and it's also not very useful here. There is a neoclassical strand of literature featuring partial equilibrium micro model or stylized general equilibrium models like the one by Fullerton and Kinnaman, where the optimal waste policy instrument is derived, which is basically a deposit refund scheme, in different situations according to the possible presence of, for example, illegal disposal, substitutability with virgin materials, and so on and so forth. Also, there is a now large literature concerning behavioral aspects related to waste behaviors. And these are, the mentioned ones are just a few examples of papers dealing with issues like social norms, warm glow, and so on and so forth. And finally, there is a huge empirical literature that tries to deal with waste production at the macro and micro level, focusing on drivers, on management, and the role of policy. Then there is a second trend of literature our work is linked to, which is the literature on DSGE modeling, and more specifically, the literature related to DSGE in general, and more closely to our paper, the more recent literature related to the application of DSGE models to environmental policy problems. So, for example, the paper by Annichiarico and Didio that focuses on the present focuses on carbon policies in a model where the business cycle is explicitly accounted for, and also papers by Amedeo Argentiero with other co-authors who focuses instead on renewable energy sources. And so our modeling strategy is based on these models related to the modelization of renewable energy and carbon policies in the context of DSG models that try to understand what happens when a shock affects the economy. And finally, we link to the very recent strand of the literature related to COVID-19. So it's not easy to provide a full detail of this kind of literature, but what I can say is that I can provide you some examples. So there is an increasing literature that tries to understand what are the links, the empirical links between COVID-19 mortality and environmental quality. For example, there is a recent special issue on environmental and resource economics, and I mentioned the paper by Coker and others, or other papers for the US, for example, the one by Xiao and others, who find an association between particulate matter exposure and COVID-19 mortality. And also, I did some wrong copy and paste here, but anyway, there is also an increasing literature. I can provide I will provide the details in the corrected version of the slides, but there is an increasing literature that suggests that there is indeed a direct impact of COVID-19 in terms of waste production. So, for example, there is a very recent paper on Science where it is suggested that during the pandemic, so far, there has been an increase in plastic packaging waste by around 5.5%. And most of this increase is related to the pandemic, which means, for example, increasing use of plastics in tools for health protection, or due to people increasing the use of single plastic for food, for example. And also, this trend of literature suggests that indeed there is an increasing impact on waste production, which is directly related to COVID-19. This is important because there are also, in general, health impacts related to waste management. And so if we assume that, if we look at the fact that there is an impact on waste production, and if we look at the fact that waste management indeed implies impacts on health, then we can have an indirect way in which worsening waste management during COVID-19 may trigger adverse environmental and health impacts. Okay. Finally, there is a small to acknowledge literature which adopts itself a DSG approach to try to understand what is the impact of COVID-19 on economic sectors. And for example, there is this Young and others paper in 2020 that focuses on the touristic sector. So it's different from our perspective, because in our setting, we do not specifically focus, even though we get results for output, we do not, this is not at the central point of our paper. So we are not interested in modeling specifically the economic downturn. The economic downturn is one of the effects of the pandemic, but is not the one we are mostly interested in. Okay, this is more or less, we try to condense the structure of our model in a single slide. So the model is not very surprising in several respects. We have a model where we have firms and households. Households derive utility from consumption that may be recyclable and non-recyclable, and the government may subsidize recyclable consumption and tax non-recyclable consumption, and can use the proceeds also to provide recycling quality, for example, better sorted collection facilities. These affect, together with recyclable consumption, the amount of recyclable waste that can be reused in the production of recyclable output, and together with non-recyclable output, this is the output of firms, that contributes to consumption and investment by households, and then the whole story begins again. So the model is not really something very surprising. What is important here is the role played by environmental quality and health, because we have that health affects labor productivity. So a better health improves improves productivity in both sectors. Health improves utility, but on the other hand, non-recyclable consumption contributes in a negative way to health due to environmental damages linked to landfilling and to incineration, and this implies an increase in the stock of pollution, and this increase in the stock of pollution also implies a worsening health. And this is how health is modeled in our setting. So the health stock is, there is a depreciation delta H for health, and there is a variable GT which takes value 1 if there is a pandemic shock. And then when there is a pandemic shock, health is worsened by the pandemic shock itself, by the degree of the pandemic shock, but is also affected positively by the use of non-recyclable waste to cope with the pandemic. And the typical example in this respect is face masks. Face masks are an example of a non-recyclable consumption that is increased by the presence of the pandemic. Okay, and then of course as also decreases with Z, which is the stock of environmental damages. Okay, then, this is, I don't have time, but of course, as part of the DSG strategy, we have the need to provide parameter values for a series of parameters. Most of the data that we use comes from Eurostat and ISPRA. Specific data, I can give you details if you are interested, are taken from the existing literature. So we had to rely on data from ISPRA, for example, to calculate a value for recycling quality. And we used as proxy the percentage of municipalities using a point tariff in waste management. Or we had, for example, to model the share of non-recyclable consumption, like face masks, to cope with COVID-19, and we used available data concerning the increase in waste production that has been estimated by ISPRA in terms of the impact on waste production of face masks. All data refer, wherever possible, to Italy. When we could not find data for Italy, we went for data from the European Union. Okay, let me just focus on two. Given that I don't have much time, I will only focus on the main part, on the most interesting, I think, part. So this is the pandemic shock. The pandemic shock is when our variable G, as I mentioned before, becomes 1. So in our model, the pandemic shock implies that all of a sudden, our variable G becomes 1, and then it goes to 0 over the time. And then what we have here, what we can observe here is that look at the instant impacts. We have a decrease in output, a decrease in the use of capital, but we have a decrease in employment, which is NR in the recyclable sector, but we have an increase in employment in the non-recyclable sector. Okay, this is the first thing that kind of surprised us. The second one is then we can also see what are the impact on ER and the NR are the use of virgin materials, and RW is the use of recyclable waste. So overall, the pandemic shock has a depressing impact on the economy, with the exception of employment in the non-renewable, in the non-recyclable sector. And this is in a part linked to the fact that we need non-recyclable output in order to protect ourselves from the pandemic. And also this is confirmed by the fact that if you look at this graph, non-recyclable consumption is almost constant, close to the shock, while recyclable consumption decreases a lot, which means that we have an increase in the share of non-recyclable consumption over total consumption, which confirms the idea that there is this ideal trade-off between environmental quality and the need to keep ourselves safe. Okay, so the overall impact on the amount of on the stock of environmental damages, which is Z in this graph, is a negative one. So as it happened, the environmental impact decreases. But anyway, what we see here is that also health decreases due to the pandemic. So what we see here is that in order to keep the health impact of the pandemic as low as possible, taking for granted that there is indeed a negative shock on the economy as a whole, we have this trade-off. In order to improve our health resilience, we need to increase non-recyclable consumption, and we have to keep non-recyclable production more or less constant. Okay, so and this is suggestive that something bad may happen in the longer term because of this need to, let's say, replace recyclable consumption with non-recyclable consumption due to the pandemic. Overall, and I know I'm running out of time, so I will go immediately to the conclusion, also because I want to say one word at the end. Overall, what we see is that in the model, we also try to model several other kinds of shocks. So we have total factor productivity shocks and taste shocks. Taste means people prefer more recyclable consumption than expected or more non-recyclable consumption than expected. And all the total factor productivity and taste shocks work in the expected direction. Okay, so we have substitution of output and consumption depending on what is the kind of consumption and production which is affected by the shock. We also model policy shocks in terms of taxation of non-recyclable output, not recyclable consumption, or subsidization of recyclable consumption. What we get is something which is, again, expected, although in the case of the policy shock, in terms of taxation of non-recyclable consumption, we also observe some hints that some crowding out may take place. Okay, so of course, this depends on the parameter values. So what we need to do now, and the final step of our research, which is still ongoing, is something that we will need to understand the sensitivity of our results to parameter values and to understand how the model results change if we change some key parameter values, such as those related to the COVID-19. But overall, what I would suggest is that our setting is capable of giving us an interesting and challenging idea of the impact of these shocks, including the pandemic, in the short term. And this is something that, to my knowledge, is not yet investigated in the literature. Okay, I'm done, and thanks a lot for your patience, but I just wanted to mention that there is an open call for a virtual special issue on the journal Waste Management. I am a guest co-editor with Shun Manarji and Antonio Massarutto, so I'm not saying a lot about this, but you can go to the web page of the journal, and the deadline for full paper submission is the end of June. So given that this is indeed a special issue which is linked to the things that are reported, that are presented in this workshop, I would invite you to have a look. Okay, thanks a lot, and sorry, I'm sorry with, I apologize with Marianna and with the audience for going beyond my time. Thanks a lot. I am putting in the chat the link to the Google Meet. If you are interested in meeting me, I will be there between 4 and 4:30.
Thank you, Alessio. You are completely on time, don't worry. And also, if someone has a question for Alessio, you can raise your hand. I just see Matteo, but I don't know if it's because he raised his hand before.
Oh no, it's okay. It's okay. It's mine. It's mine.
Okay. Okay.
Am I only the only one?
Yeah. Just go ahead.
Okay, thank you. No, I was interested in the division renewable and non-renewable labors. In case you want to make an application in real life, where would you make the reference in real life workers?
Okay, thanks a lot. Yeah, this is I mean, an interesting and let me say maybe straightforward question, in the sense that in real life, if you look at the model in a micro perspective, then what you could do is simply suggest that you take recycled and non-recycled paper production, for example. But the problem is that one of the main issues related to the need to calibrate the model is that this is a macro model. Okay, so basically what we need to do is to specify an aggregate production function that takes an average of all the features of the production function of recyclable goods. Okay, and this is made worse by the fact that we need to kind of segregate completely the two sectors. Okay, so we have two sectors that go in parallel. One is the recyclable sector and one is the non-recyclable sector. So if you ask me how I calculate the parameters, I can tell you that we tried two ways. One is calculating it on the basis of the share of energy from waste on energy from fossil fuels. Okay, and the second one is taking statistics from the European Union on Eurostat on the amount, on the share of recycled content of products produced based on metals, such as aluminium, copper, etc. That's the best answer I can give you.
Yeah, I agree. That's a very, because there is quite the availability on Eurostat. So I would have done. I mean, it's a very interesting paper, and I hope I can see it as fast as I can on a journal. I hope.
Yeah, me too. No, but it's very
Thank you a lot. Thank you.
I can send it to you in advance once it's written.
Okay, perfect. That gives very several suggestions for future studies.
Yeah, I agree.
Thank you very much. So anyone else that wants to come up? Okay, so yeah, by the way, Alessio and also Chiara, I remember they put the link for having a coffee break with them later. So thank you very much, Alessio.
Thanks, Marianna. Thanks to all.
And we go to the last presenter, which is Matteo. Again?
Oh, come on.
Yes.
No, joking. Thank you.
Yeah, you are the first and the last, so yeah.
Okay,
And
thank you all.
yeah, the timing is the same as before, and yeah. So your paper, the paper that you are presenting now, is cyclical and non-cyclical shocks on recycling. So if you want to share your screen and your slide with us.
Okay. Okay. Thank you all for the patience, for hearing me twice this day. And okay, can you see the presentation?
No, I can see your Google Meet.
Okay. Let's try again. Sorry. Okay.
Okay, great. Now we can see it. Thank you.
Okay, perfect. So since this is the last article of my PhD thesis, so you can see that there are some idiosyncrasies in terms of issues, arguments, and so on. So we can basically jump to several several slides. So the first thing that you are going to see is that basically since accumulation and recycling potential are somewhat correlated, you can somewhat predict external shocks and non-transitory shocks to this potential. But so in some sense, the article has changed quite a bit since the submission to the workshop, fortunately. And so I focused more on material accumulation and specifically to the electrical equipment rather than recycling. So I hope that it is not that big change. So we speak before about accumulation of electrical equipment, and we basically understand now how data are created. But in terms of studies, there are not that many that address. Yes.
Anche per pulire un po'. Sì, per metterti a streghe, perché c'era da staccare il filo della condensa.
Jacopo, please, could you mute yourself? Don't worry. It's fine.
I'm very sorry.
Okay.
Sorry.
Thank you. So where were we? We were exactly on, in terms of literature. Basically, it's not easy to find articles that speak about accumulation of electrical equipment, or you have something about material accumulation in general. But this one is very specific, and it works especially for this kind of commodities. And there are drivers that can specify accumulation and diversification. We are going to focus to present those in this paper. And I was interested also, since we understand, since we have seen that circularity can affect production of commodities and reduce the amount of waste. I was thinking, wait, is it possible that waste policies and innovation in waste recycling affect material accumulation also in electrical equipment? So I thought, okay, let's see if there is an effect in policy breaks and innovation accumulation. If accumulation of patents and so on affect the stock of in-use electrical equipment. So basically, since this is it's not a novelty per se, but it has some new aspects. I thought it was interesting to add a little theoretical model. So I hope it is not too much. I focused on some aspect of the theoretical model, so I will not spend too much time on it. But the main aspect is the estimation of the driver's impact, and so there is also an econometric exercise in this chapter. So let's first start with the theoretical one. The basic idea is that you can solve the circular economy growth model as a dynamic optimization, where you have basically full information of the future innovation, accumulation, consumption, and so on. So you have three variables that you want to optimize: net additions, and we've seen before how they work. You want to add new stock to this economy. new material stock, you want to consume as much as possible, and you want to invest as much as possible in innovation. So but you, of course, you have dynamic constraints, you have limits, and these are the material accumulation, which is driven by this equation. You have technological stock, which basically it's the net addition of investment. Of course, you have some smoothing parameter, which tells you about how much you're successful in accumulating the information capital, and then you have the famous generic capital. Since I've made the article before about the maximum potential, I thought that you cannot recover all of the discarded materials, which is this is the spent factor. This is the stock, the material stock. So you cannot recover exactly all the spent waste. You cannot see. You can only recover a maximum potential that you can reach after investing quite amount of resources. And basically, the economic constraint works with investment, which is the available, which is basically the production minus consumption, and this is the investment constraint. The production is a very, very interesting matching, because you have three main sectors. When an economy starts to reuse part of the stock, material stock, will have this third input, but you see here that it is actually just a repetition of in-use stock, so you can somewhat remove it. Take it here, and if you consider this as some sort of productivity, let's say circular productivity, you can easily see that the problem from 3 inputs become basically easily a 3 inputs system. So what you want to maximize is consumption. You want to reduce as much as possible the hazardous waste of non-recovered waste. So it's the reciprocal of G1 minus G. And the objective function is basically to maximize this over time and discounted by some discounting factor. So what's the purpose of these stocks? So the first one is to foster material recovery. The second one, so the general capital, is to finance the overall budget, and it is a production input. Plus you have material stock, which is basically it's the circularity within the economic system. So it describes how you accumulate flows, how it is generated waste, and how much it is the potential recovery. So what's exactly what are we interested in practicality? So D is the percentage of spent stock annually, and here it is exogenous, but in reality we have seen it before. It varies across commodities, and you see that commodities sometimes they tend to be less durable in time, or sometimes they are more durable. So it is not. It is an uncertainty. In reality, this is quite uncertain, this factor. Then you have G, the potential recovery, which is determined basically by accumulated knowledge, but it has always a maximum potential of A. So the second, so just to take stock, let's say, of the solutions, you want to study the tipping points basically of material accumulation, because you cannot accumulate as much as you want. So in terms of production, you see that economic activity will have to tip material accumulation at a certain level, and you have apparently also something in terms of circular innovation. So this is the theoretical premise of the application of the study, the economic exercise. So there must be some relation between a positive relation between economic circularity and material accumulation. So, and when you see about potential recovery, we've seen it that it varies across commodities. So you want to see it how exactly how differentiation is affected by these commodities. And I tried. It's not clear here, but basically this is the Shannon index that we've seen before, and there must be some relation with these other variables. So accumulation, economic growth, and innovation. So basically, this is just taking stock of the situation. So material accumulation could be decoupled by economic cycle and circular, and it is related to circular innovation. Intrinsic variables such as time span affects material accumulation. And distribution of net addition is strongly related to tipping points. So there is something that we have to tackle in this way. And how do we estimate this? So of course we have cross-sectional dependence because you have international trade, interactions, and so on. You have unit roots because innovation capital is basically a repetition of in time of something. So you must have some unit roots. We are not interested in capturing complex effects, of course, so we just use feasible generalized least square. So we remove the outliers. We also use control for policy breaks in 2008 and 2012. So let's see the data. This is something that, of course, it is not new to the Platia. So I've seen that you have some changes across strata and commodities. And let's dig in to the data, especially. So you have 28 countries in 17 years coming from the PROSEN project, calculated on inflow-driven methodology. You have socioeconomic variables. I use the GDP per capita for tipping points and the percentage of elderly population, so after 65 years, because they tend to consume less about technological equipment, so they probably can affect the differences in the stock, so the shares of single commodities, but probably not exactly in accumulation. So in terms of intrinsic variables, we have an average time span. We have the Shannon index of concentration and stock per capita. Then we have the techno-policy one, which are represented by cumulative patents and breaks of waste packages in 2012 and the waste framework directive in 2008. So this is basically the summary data for our paper, and you see that so it is quite specific, and it is quite a wide range of observation. And in terms of concentration, you see that stock per capita doesn't vary that much. It is a very normal distribution. Shannon index as well. The average time span is very concentrated around the mean. Well, for GDP per capita, we cannot say the same for European Union, and it's basically the same for so the socioeconomic variables are quite vary across the system. The same we can say for cumulative patents, and these are the two breaks. And let's see how these variables interact with material accumulation and differentiation. So in terms of results, we basically done the same as before. So we tried to see if there were strong heterogeneity between the clusters, the geographical and historical clusters, in terms of terciles. And let's see the monstrosity. So basically, you see that there is some cycles in terms of material accumulation and diversity within the stock, and you see that basically the intrinsic variables are quite always significant. So especially time span affects both the Shannon index and the material accumulation. So the longer you have commodities, probably this affects somewhat how much you can accumulate in long time, because you don't waste them. So if you don't waste them, the stock doesn't reduce. That's a very interesting fact. In terms of the percentage of population, of elderly population, it affects the composition of the stock, but it doesn't affect the stock per se. So that's quite interesting for policies, and it's not significant all the time. But this is probably the most interesting one. So cumulative patents affect always and very similarly across Europe the accumulation of stock. And why, you would say? Well, if you have circular economic policies in place, you are probably reducing waste, and if you reduce waste, it stick within the stock basically. And this is the same. So the techno policy drivers are increasing the amount of stock, and it is basically similar overall the stratas. You see also that socioeconomic drivers are similarly affecting the system. You have basically the same exact estimates across strata. But I think that the most if you think about the predictability of the problem, the predictability, you see that we can basically predict very, very easily stock across that time. It's 90%. If you compare with the diversity, it's easier to predict the gross math. But what can we say about these results? So you can predict the accumulation with commodities and commodity distribution, but with socioeconomic variables. And very interestingly, circular innovation and waste policy affect stock accumulation, at least for electrical equipment, and the intrinsic variables are significant and effective. Plus, there is somewhat a divergence in results according to strata. But I think this is mainly for time, and it is mainly in fixed effect. Plus, in terms of possible conclusion in long term, you see that we can use, theoretical models we have seen in this session. We have many. We can produce many in this network. But about the estimation, this is quite a novelty, because you can see that circular innovation affects how we accumulate, and how not only how we treat, but how we accumulate commodities. And I think this is something that it is worth studying a little more. In terms of future research, I was interested in. I think it is very, very relevant to add a certain level of uncertainty to the innovation effect. So in the theoretical model, I thought that the success function, basically the more you invest, the more you accumulate. But in reality, it's not that simple. So probably you invest, but you will not success in producing patents that will not probably affect sustainable targets that easily. So that could be a very interesting way to test the feasibility of certain policies in long term. But this is just for a very, very small, although useful, very small quota of production of commodities. So how does it work with transport sector or automotive in particular, or airborne and so on? So these were the main factors that drove the conclusion of the paper. And I hope that it was somewhat insightful. Thank you for your time. I hope you have questions.
Thank you, Matteo. So if anyone has a question, you can raise your hand. Okay, so I have a question actually, and it's a very simple one. So you said that there are geographical differences between your countries, but you can say that only because you have used GDP to separate your sample in 3 parts. And so my question is, if your intention is to investigate the geographical differences more in depth by, for example, accounting only for northern countries and only for southern countries and so on.
Okay, yeah, it's a very interesting aspect. So I use the stratum approach because it's very easy to divide nations for economic activity, but probably it's very, very more interesting to say, for example, the historic to highlight the historical differences. So Eastern countries, since they were since the 90s up to the 90s, communist nations, probably the accumulation of particular commodities was a little different than in our countries. So somehow we should consider then that factor in when we consider circular policies, their effect, sorry, and so on. So yeah, I think I will do it in the future research. Thank you.
Yeah, thank you. So, anyone? Don't be shy. Okay, so I can say that this session is ended. I really thank you very much for having been here this afternoon, and we can leave it to the coffee break and have a coffee break before the coffee break. So thank you very much and have a good afternoon.
Thank you, Marianna. Thank you to all and for suggestions.
Thanks a lot, Marianna. Thanks, everybody.
Thank you, Marianna.
Bye-bye.
Thanks.
Thank you.
Thank you.
Thank you, Marianna.
From my side as well. I'm very sorry for my intrusion before.
Oh, don't worry.
Okay. Thanks. I think we will have a longer break until 4:30 p.m. Okay.
Okay, 4:30 p.m. we start again.
Okay, see you later.
See you later.
See you.
Bye.
Thank you, Marianna. Bye-bye.
Bye.
Hello, everybody. Can someone hear me?
Yes.
Is somebody there? I don't see anyone.
Yes, we can hear you.
Right.
Good afternoon, Sandro.
Good afternoon. Good afternoon, Fabio. Hi, everybody. So, as I don't see any camera on, I'm just talking in the dark. Yeah. Thanks for showing up. At least I can see that there's someone around. I'm Sandro Montresor, and I'm supposed to chair the session that is about to start in 3 minutes. So I want to first of all to see, Jacopo has just joined the session. Hi, Jacopo, good to see you. I see you over there.
Hi.
Hi,
Sandro.
Hi. Yeah, I mean, we still have a couple of minutes before starting the session, but what about if we somehow see whether all the presenters are here? So the first presenter should be Rosiek Ximena.
Yes, Ximena Rosiek. I'm here.
Please apologize me for having bloody mistaken your name.
No, it is not a
please
mistake.
Apologize. I might instead go easily with Leo. Leo is there. Is Leo around? Leo Minervini, who's gonna present. Leo, are you there?
Hi.
Oh, hi. Okay, you are there.
Yes, I am.
Yeah.
Yes.
Then, yes, I can hear you. Then we have a paper number 3 by Anna Dalla Valle should be the presenter. Anna, can you give me a voice if you are here? It's not here yet. No, you're yet. And then paper number 4, where the presenter should be Erika Mancuso.
Fabio speaking here is the co-author of Erika.
Yeah.
She's coming back in a while.
But is she presenting or yourself?
For sure. No,
Okay.
she's presenting.
Okay. So with that, we only need to recap that we have a speaker for paper number 3, remanufacturing and reuse networks for tertiary architectures. There's a bunch of authors, and I don't know, Atta, Anna Dalla Valle, Macri, Ratti, Viscuso, Arena, Ciampoli, Lavagna, but just the list of names is longer than the title. That was likely the same. So again, is Anna Dalla Valle around? I don't see her. I don't know. She might join the session later.
Sandro, perhaps she will join us in a few minutes.
Yeah. Maybe it is going to be later. The important thing that we have the first speaker actually. So I will wait just for 1 minute more to leave people time, to move from one session to another, or from coffee or other alternatives, occupation of time to the webinar, and then I'm gonna start. But again, let us wait until 4:31. Okay, now it is 4:31. So I think that I've been tolerant and flexible enough to give 1 minute or more. Okay, so welcome everybody to this session number 4 of a workshop on making the circular economy work through sustainability. Okay, the section works in the domain of urban and industrial areas. I'm gonna chair the session. For those of you who do not know me, I'm Sandro Montresor, and I'm professor of applied economics at the Gran Sasso Science Institute of L'Aquila. Okay, so before starting, the rules of the game are the following. We have basically 30 minutes time for each and every paper. and therefore, if you agree, we'll leave each presenter 20 minutes time, okay? And leave the remaining 10 minutes for the discussion, so for collecting questions and leave the speakers the opportunity to reply, okay? In terms of posing questions, I would suggest that if there are spotlight questions, so instantaneous kind of questions, attendees, please drop me a line in the chat. Okay, so if you have clarification question, I will be glad to pick it up from the chat and pose it to the speakers. Okay, while for more structured kind of questions at the end of a presentation, I would suggest everybody to use the raise hand option. Okay, right. So if everything is clear, I will leave the virtual floor to the first speaker, reminding her that the time available is, again, 20 minutes.
Okay.
If you don't mind, I will remind you when you have 5 minutes left. Okay?
Okay.
Okay, so the floor is yours. Maybe you want to share your presentation?
Okay. Hello, everybody. My name is Ximena Rosiek. First of all, I put into chat my Google link to meeting. And now I would like to share my presentation. This one, okay.
We don't see you yet.
Okay.
Yeah,
and
no,
yes, okay. It's working.
Yeah.
But I should. I want to ask if you see my presentation or.
We do it, but not in the full screen mode.
Okay, so I put.
We can see it now. Okay, thank you.
Okay, now it is full screen. Okay, so once more, my name is Ximena Rosiek. I work in Krakow University of Economics in Poland, and my focus today is to present my piece of my research connected with water usage. Mainly in cities, in the context of the circular economy. And I think that it is very important not only focus not only on new technologies and innovative solutions, but also at the same time we should prepare to measurement of outcomes of our interventions. And that's why I decided to focus on available indicators in Eurostat databases. And I try to collect them and check how useful they can be in describing circular changes in water usage in urban area, in economy and in urban area. So first of all, I would like to say quickly that water is circular by its nature, but we get used to its linear usage. And according to circular economy approach, we should reuse, recycle, replenish water, both in the natural-based cycle and human-managed cycle. And what I've noticed is that water, other than tap water, is very often seen as sewage. But still it is a very valuable resources and should be and can be used for many purposes, and we should take into consideration the quality of water that is needed for each process, both in households and in the industry. So I think that in the context of circular economy, the special attention should be put to not potable water, and we should define where sources of this water appear, how often, how regular, and try to combine this information and compare them and prepare to use, reuse, or recycle water. And I divided this non-potable sources of water into 3 groups. So reused water, non-fresh water, I mean salted water, and post-industrial water. I know that this classification is not very sharp, because, for example, both categories, purified municipal water, wastewater, and purified industrial wastewater, actually should be put in one category, because water from wastewater treatment plant actually is water from industry. But in all statistical databases, wastewater treatment is divided from industrial sources of wastewater. So I decided to do the same and underline that the purified municipal wastewater is important sources of water, especially in the city. And in this place, I would like to underline that the new regulation, EU regulation about reused water, is prepared, but it cover only municipal sewage water from municipal wastewater treatment, and only for agricultural use. And I think that the approach to the reuse or recycle water in the city should be wider. Yes, now I would like to move to the second part of my presentation. And in this part, I redefine the 3 main principles of circular economy to the water, let's say, water language. And these rules are taken from Ellen MacArthur Foundation documents. I actually I would like to show this rules. I think that on the general level, they are well known for everybody that participate in this seminar. And I would like to focus on the third part of my presentation. So I would like to move quickly and smoothly to the indicators. Of course, I can send this presentation to participants if anyone is interested in it. So let's move to the core part of my today's presentation about measurement of water circularity and what we can get from Eurostat databases. First of all, I would like to say that in case of waste, the situation is much more better than in water sector in describing in data describing water sector, and as I saw on this seminar, those data are very useful for researcher, and in the area of water, the situation isn't so good. But started from the main level, we can find water data in at least 4 parts of Eurostat databases. First of all, environmental statistics. Then thematic statistics, so dedicated to strategies or important topics. About ecosystem data about ecosystem accounts, they are still creating. And system of environmental economic accounting. And this system of accounting is still under construction. First of all, data in the part of environmental statistics are served in two main blocks. So about water in administrative borders and water data about water based on river basin level. But we can find similar indicators. I think that they are well known because we often use them. So indicators connected with water infrastructure, water abstraction, access to the infrastructure, floods, desalinated water. And I found a very promising indicator, reused water. But so this indicator can be very useful from the perspective of circular economy. But when I try to develop the databases, it looks like that. So there is almost no data, and so we predict the possibility of introduce. So this indicator exists, but there is no important information because countries don't put information indicators in this for this indicator. And we can when we move to the next block of statistics, so thematic indicators, we can look for water indicators in several parts of it, like for example, climate adaptation, city statistics, river basin districts, sustainable development, resource efficiency scoreboard, circular economy indicators. And I would like to focus only on part of them, and I analyzed indicators connected with climate adaptation, city statistics, and circular economy statistics. So let's move to the first block of our indicators. In breaks, I put the numbers of the statistical name of this indicator. And actually, in the climate adaptation part, we can only find the general information about water productivity and water index, exploitation index by type of water sources. But I think that they are very useful from the perspective of a circular economy. Because the first one inform us about how much we can produce from on the basis of usage 1 meter of water. And the second one inform us about pressure on the water resources. So we can adapt these indicators for a circular economy purpose. In the city statistics, data are collected in, as far as I remember, about 5 groups, but 2 of them can be interesting. So cities and greater cities and functional urban areas. Indicators in both categories are similar. And for example, in the indicator which should inform us about rainfall, actually there is no data reported. And the next 3, so total usage of water in selected cities. So it is not information about general total in the total use of water in economy, but in selected cities. And so those 3 indicators data are partly available, but it is not enough for good statistical analysis. I found also a group of indicators named
you still have 5 minutes to go, huh? Okay.
Okay, I'm close to the end. Okay, thank you. So in living conditions, and there is no data about water usage. The same situation is in circular economy indicators. There is no single indicator about water usage. So I think that it is it should be developed. And the last part of CEA accounts, they are not introduced yet, because water was put into third package of indicators that should be introduced to statistical systems. And I think that these indicators can be very useful for describing circular economy outcomes, and they should be introduced to the statistical system as quick as possible. I know that countries have got difficulties with finding information, but it could be very, very useful. Okay, here is only information, confirmation of information that data about water are not collected yet in the CEA, and my conclusions. So, in the opposite to waste statistics, water statistics are very poor. There are no indicators, or there are no data. So it is really necessary to put attention to collect better data about water in Eurostat. And I think that the water accounts in CEA accounts are, so a system of environmental and economic accounts is very useful, could be very useful for this purpose. also because it can be easily compared, for example, with information about energy issues. And here are some indicators that, in my opinion, should be introduced to the system, except the mentioned before. And what else? Sources, and that's all what I've prepared for today. I know that it was a little bit theoretical presentation, but I think that it has very practical impact because we have to improve the data collected about the water data in a statistical system, and in this way we can develop better, we can define better goals and measure how we achieved them. Thank you very much for your attention.
Right, thank you very much to you for this interesting presentation. It's now time to have some discussion about your talk. I don't know whether there are questions from the floor about your presentation. If there are, please feel free to raise your hand. When there's apparently nothing in the chat, and I don't see raise hands from the floor, so I might pose a question myself. Yeah, I mean, the picture that you present about the statistics about water is indeed quite gloomy. I mean, if I were a statistician, if I were a researcher with a special interest in water usage and in the circular use of water, I would be very disappointed, actually. Oh, sorry, that reminds me that the time was gone. But now the question is, did you try to investigate which is the ultimate reason for this lack of data? Because apparently...
I'm sorry. Proszę cię wyjść natychmiast. Wyjdź stąd. I'm sorry.
Don't worry. I got pretty similar problems like yours. So I'm in office and my son can pop in, but when I'm on the web, usually my son come and say goodbye to everybody. So, yeah. So my welcome and goodbye to your son. But so going back to my question, as I said, do you have any idea or did you explore which might be the ultimate reason for this lack of data? I mean, is it an issue of not having micro data, that is micro units of analysis at the industry, the residential level that do not collect this data? Or is it rather a problem of assembling and aggregating this data from the micro to to the macro level? So where's the bottleneck? Where's the bottleneck in the creation of these statistics? Did you investigate this by chance?
Yes. So first of all, we've got the micro data. So we collect data about water usage in the economy, in the sector of economy. So for agriculture, for industry, and for households. But to measure the outcome of circular economy, the first problem is that there is no disaggregation of this data for lower levels. The second issue is that we collect a lot of data, and I suppose that during last 10 or 15 years, the main concern in water statistics was to collect data about floods and water quality. There was no detailed data how we use exactly this water in the economy. So how water flows, how water flows are created in the economy. and we needed the physical water accounts. It is a part of a system of environmental economic accounting, which offer us such statistics. And environmental system of environmental economic accounts are a little bit different from environmental statistics, mainly because they are connected not with the place where water is or any resource is water is taken, or wastewater is how to say it? So it is not the place of usage is important, but the information is connected with entity.
Right.
So.
Right.
So it is easier to follow how this water flow in economy.
Right.
And that's why this should
sorry
be.
if I interrupt you, but I would like to collect at least another question. I've seen that Greta Sunderman has raised her hand. Greta, please go ahead. Are you there? That was a raised hand. Is it a null one? Hello? Maybe there's what's not.
Oh, excuse me. I think I raised my hand by accident.
You raised it by accident, right? So, right. Okay. So we thank you for this interesting presentation, anyhow, and we.
Excuse me.
Oh, there's a comment in the chat. There's a comment in the chat. Let me see. Ximena, do you think whether data are reliable? Andrea Ponti says. I don't know whether Andrea is in and wants to rise. Oh, there's also Andrea Molocchi wants to raise a question. So Andrea Ponti rises in the chat and he asks about the reliability of these data. Could you provide a short answer to that?
I think that we have to. It is necessary to introduce a system, the third part of system of environmental and economic accounting, which introduce to statistical system water accounts and, for example, forest accounts. Without that, we will not get the data we need to describe water usage in economy in the context of sustainability and circular economy. It is, in my opinion, it is the only one way.
Good. So, Andrea Molocchi, you want to ask a question?
Yes, thank you. Thank you, Ximena. Many compliments. I think this is a very practical contribute, but I think it's very useful to have a wide overview on the available indicators. So your contribute, I think, is very appreciated. And I would like to put a question on the availability of economic indicators on the value of water, on the price of water. In particular, I know there are some indicators at the level of the household, so potable water. But which is your experience on other uses, such as the agriculture uses or industrial uses? Did you find any indicators, at least some countries that are trying to improve their accounts on such usage?
Actually, first of all, data about price of water in terms of household usage are very incomplete, and sometimes there are difficult to collect, but it is not the place to discuss it. And actually, I haven't found information about pricing water in agriculture or or for industrial purpose. And I think that now the only way for finding such information is to develop the research papers and to find information from researchers from particular countries. I know that it can be strange for people who deal more with waste, because waste databases were developed during last 10 years very, very deeply. They really collect a lot of information, and we can say a lot about this sector. But in the water sector, the situation is completely opposite. We have no good data except information about flood to describe water in the economy.
Right. Okay. Thank you very much, Dad.
Thank you.
I think that was quite good, and I just have 2 minutes late. So let us go ahead with the second paper, whose presenter should be Leo Minervini, right?
Yes.
Leo, good.
Yes.
So Leo, same rules for you, okay? So you have 20 minutes time for presenting. I'm gonna alert you when you have 5 minutes left, okay?
Okay.
Please go ahead.
Thank you. I will upload my presentation. Okay. Let me see. Can you see my? No, not yet. Maybe.
We see your desktop, and now we can see your presentation.
Presentation. Okay. Presentation from the beginning. Okay. So now we are there. Okay.
Yeah.
Okay. Thank you very much. And thank you for this invitation to present my work. This is a joint work with Roy Cerqueti and Matteo Cinelli. I am Leo Fulvio Minervini, and I work in Macerata, University of Macerata, Department of Economics and Law. My presentation, as you can see, is about municipal waste collection and management, and we use a complex network approach, which is maybe the most interesting part of this presentation, as we suggest this approach in order to deal with waste management issues. Now I will give you some information about the motivation and the outline of my presentation. Of course, we know that separate waste collection and waste disposal services can help significantly in reducing environmental pollution due to waste. Waste collection is usually organized, and it's a responsibility of local authorities. Choices on waste management issues have impacts that go beyond administrative boundaries anyway, and so municipal waste management offers a very fragmented picture at various geographic levels. And there are some collaborations and cooperations among intermunicipal governments, but actually the impact of these collaboration is still very limited. We see that there is research, for example, especially on circular economy, sustainable development, which puts emphasis on convergence issues with regard to waste management targets, for example. And we want to show the possible application of complex networks to this field of research, to waste management. And our aim is to contribute to the analysis of waste management issues, actually. And we focus on two aspects. The first aspect is the percentage of sorted waste which is achieved by a municipality, and the other aspect is about the distance that is traveled in order to deliver the waste to waste treatment plants. Complex networks can be used to study, for example, proximity and peers effects, and it can also be used to support decision making. And we are particularly interested in finding out whether more granular data, especially with an application to the case of Italy, might help detect somewhat homogeneous communities of municipalities. Actually, what we do is a community detection exercise. And as I said before, there will be actually two networks because we will investigate two separate issues. One issue is the separate waste collection, which is done at municipal level in Italy. And the other network is about the transfer of waste to waste treatment plants. We will use, in order to provide an example of the application of this complex network approach, data provided by the Italian Ministry of Economics. And results show that clusters, which in this case we will call communities, are quite different and they do not overlap. Clusters detected inside the two networks, as specified above. Results confirm, with regard to the Italian case, that the most virtuous municipalities, I mean those that have high percentages of sorted waste, are by and large in northern Italy, but at the same time our community detection method offers further insights, as we will see. And with regard to distance-based communities, I mean those detected in network number 2, we obtain a quite heterogeneous distribution of nodes among Italian regions. And I will shortly discuss the implications of this analysis. Here is the structure of the presentation. I will spend a few words to describe on a very superficial level the complex network approach. Then I will give some information about the data that we use to test our network models. And I will provide you the results, of course, of our research, and some discussion and concluding remarks will follow. Here, please do not consider the queue in this picture. I will turn to this later on, to the queue. This is only to provide you the idea of graphs and networks. We have nodes, which are the circles that you can see in these pictures. We have blue, red, and yellow nodes, and these nodes are connected by links or arcs. So this is what we do with municipalities in our exercise. So every circle will be a municipality, and we will then use data from Italy to detect communities of Italian municipalities with regard to two aspects of waste management, the aspects that I mentioned above. So as I showed in the previous slide, you have an idea of what a network and a graph is. Actually, the theory of networks is based on the theory of graphs. And we will construct two networks. We will call the first network the network with percentages of selected waste NP. P stands for percentage. And we will denote ND, the network with distance traveled from plants. Now I probably will not go into many details of the construction of the models, but of course, if we consider the network with percentages, we will use data regarding the percentage of selected waste in each municipality. And basically what we do is to consider weights for these networks. And actually the graph is a weighted graph, because we will give a weight, and then we will give a measure of how strong the connection between municipalities in the network is, and municipalities that in this case sort a very similar percentage of waste will have a similar behavior, so their link will be strong, otherwise it will be weak. We have something similar in the case of network with distance from waste treating plants. Again, if the distance from the waste treatment plants is high for both municipalities, then the link will have a higher measure, otherwise it will be a weaker link, and the number corresponding to this relation will be lower. What we do actually is to use these models to detect communities. So it's a sort of a clustering exercise, but it's a clustering exercise on networks. So what we get are communities. And we will see that communities that we will get using data from Italy in the two cases, I mean, sorted waste and distance from plants. Definition of community is a qualitative definition, and the problem of detection is open to different mathematical interpretations. Community detection is the task of partitioning a network into groups of nodes, as I tried to show you earlier. And what we use here is modularity maximization, which is one of the most popular approaches to community detection. It's modularity, which is Q. I will not go into the details, but you can, I will just tell you that it's a measure of the quality of the links between the nodes, and the nodes in our case are the municipalities. Here is the picture that I was showing earlier. As you can see, there are different values of Q showing this quality of the links. For example, in the top network, you have all circles with the blue color on the left and the red ones on the right. So modularity in this case is relatively high. It's 0.36. If you consider the graph below, the network below, then you will see that modularity is lower because on the right-hand side, we also have a blue circle, and the least value for Q is in the bottom picture, because you can see that there are nodes of different colors on both sides. Okay, so this is just to give you the idea of what modularity is going to measure in the network. Community detection method is something that actually is based on an algorithm. This has two main phases. The logic is that if the behavior of two municipalities, according, for example, to waste selection, is similar because they have a similar percentage of selected waste, then these two municipalities will be in the same community. And this is repeated over and over again with all the municipalities, and considering all the links, potentially all the links. But then in order to make our exercise a little bit more significant, we will introduce, as you will see in a subsequent slide, a threshold, so that we actually consider only the largest component of the detection exercise. And I will, okay, as I said, we use data which was provided by the Ministry of Economics, the Italian Ministry of Economics. We have data about 6,600 municipalities, more or less, so we were able to cover around 85% of the Italian municipalities, and the data refer to year 2016. One thing that we have to remember is that these data are only for regions with ordinary statute. In Italy, as you probably know, there are some regions which do not have ordinary statute, but special statute. And so data about those municipalities are not included. It's a high quality data set because actually MEF was working on another activity which is very important in order to carry out different policies in Italy. And so it is important because usually data about waste is not homogeneous. It's the quality of data is not very good. Here you can see what we have if we consider all municipalities together, for example, with regard to sorting. And here, with regard to distance, but of course we are interested in the communities. I mean, in going into more detail. And what we get with our detection method for community NP, which is the one with percentage of sorted waste, is that the algorithm with this bottom-up approach identifies 5 communities, and in this case you can see that communities B, C, D, and E have almost the same number of nodes, so the same number of municipalities which are located in those communities, or that are aggregated by the algorithm in communities B, C, D, and E. There are only 466 municipalities that are located in community A. The density, which is a measure of all possible connections among the nodes that were used for our exercise, is 0.17. This number is higher than the one that we will see in the case of network ND with distance. And what I want to show you now is this. As you can see, the segmentation, so to speak, the intervals that we get are quite clear-cut. The procedure identifies very clean and clear intervals for percentages of waste that are sorted in each community, and these percentages are not imposed ex ante, but it's a result from our data, from the data that we use. And we can also see in the following slide how these nodes are distributed over the Italian territory, and we can see pictures of Italy divided into regions. And as you see from the colors, for example, community A, which is the one that has the lowest performers, it has municipalities that are mostly located in the south of Italy. And if we look at community E, for example, then you can see that here we have Lombardia, the region Lombardia, which is doing very well, because community E, as you probably remember from the previous slide, is the one where more than 75% of sortage occurs, and Lombardia has this almost red color, so it is very, I mean, it's full of municipalities that sort a lot of their waste, and the links between these municipalities, according to our exercise, is very strong, as we could see from the measures on our network. With regard to the second network, what we see is that...
Leo, you still have 5 minutes to go.
Yes, thank you. What we see is that we get 3 communities in this case. And as I said before, 0.1 is the density, so it's much lower than the previous one. And if we see, if we have a look at this slide, what we see is that the distribution actually is very similar to the original one. So the information that we get in this case is not so revealing as the previous ones, because you can see here that in the 3 communities, the behavior is almost the same. So there are a lot of municipalities that send their waste to plants that are further than 50 kilometers. And actually, the only or the more cohesive community is community B, according to the results of our exercise. And here again, we can see how they are spread across Italy. You can see a very interesting thing, or I mean, what emerges here is that Lombardia has municipalities that belong to the 3 communities. I mean, in the case of Lombardia, there are municipalities that have different behavior, and that our network analysis approach locates in different communities. And if you look at community C, then what we can imply from that, what we can observe there, is that there is almost no cohesion among the municipalities. I mean, their behavior is still very heterogeneous from this kind of approach. Here, and now I turn to some more discussion. I have already anticipated a lot while showing the pictures. Here you can see, for example, the Q for the network with the percentage of sorted waste. Q in this case is 0.47, which is relatively high. In the case of the network with this Q, which is the measure for modularity, if you remember, is only 0.22. So we have a lower modularity, and we also had a lower density with regard to the strength of the links. So the connection in this case, and I mean, in this case also the similarity of the behavior of the municipalities in Italy is different and much weaker in the case of distance from waste treatment plants. So, okay, I've said almost everything here. Okay, the number of municipalities falling in community C, D, or E with regard to the network with the percentage of selected waste is about 4,500 municipalities. So almost 70% of the Italian municipalities are included, and 25% of them are the top performance, as I mentioned before. And what we can add to some recent research about waste sorting in Italy is that, okay, we have we can confirm that there is a north versus center-south divide in Italy. But for example, we get additional information because we can see, for instance, that contrary to maybe to what is usually believed, Campania is not so bad. I mean, the behavior of municipalities in Campania is not so bad. And we also had some observations for Lombardia, and I mean, so we can get actually a few more additional insights. The other interesting thing is that all of these observations and all these results actually are data driven. So it is not something, for example, it is different from a key means clustering, because we do not get what we get is the result is a result from the data. Obviously, it might help to investigate further the conditions which enable better performances in some communities than others. With regard to the results for the network with the distances, the algorithm does not detect very significant links, as I said. These links are less strong and less numerous. The three communities are still quite heterogeneous. Each of them includes municipalities where distances from plants vary a lot. However, as I said, community B is a little bit more cohesive. Taking into account the distribution of community nodes over the Italian territory, heterogeneity is substantially confirmed by our exercise. Heterogeneous performances, for example, in Lombardia may be due to saturation of closer plants, or there might be, not in my backyard, obstacles, something that was discussed also earlier this morning. So basically, this is the final part of my presentation. We have proposed a novel approach to waste management issues and showed an application to Italy. Complex networks and community detection may provide insights for decision making. In policy design, we might say that waste selection targets might be more effective than targets based on distance from plants. Municipal behavior dissimilar from that prevailing in its community may be worth of further investigation to try to understand why a municipality behaves in a different way with respect to its community. A repetition of our analysis with new data. For example, if we add the data for more years, we could do this again, might provide additional insights, and maybe in some kind of dynamic way, we might get some insights about converging processes. And one might be able to study bi-level networks as well. Obviously, the one that we used in this case was a one-level network, but we could differentiate, for example, with regard to different types of waste. And that's it. Thank you very much.
Okay, thank you very much for your presentation, Leo. Before going on, can I ask whether the presenter of the following paper has appeared? So do we have Anna Dalla Valle in the floor?
Hi, everyone. There will be me and Sarah. That's, yeah.
Okay, so there's a presenter for, yeah, because nobody replied to my questions. Okay, so let's go back to Leo. Very interesting paper, Leo, indeed. I'm very sympathetic with the use of network analysis, and I've also worked on community detection. I think this is a very interesting piece of paper. Is there any question from the floor? Someone want to pose question to Leo? There's a curiosity on the chat from Giovanni Turri, who said, how many of the municipality you use a sample use door-to-door trash collection service?
Well, actually, the data are only about the percentages. We do not have this kind of information. Actually, I skipped some of the information in the slide about the data, but what we have from this data set, which is provided by SOSE, I do not know, maybe some people in Italy will know what SOSE is. It provides services for the ministry, and it's public partnerships. And we have the total waste collected for each municipality. We have the percentage of selected waste. We have the distance from plants, and we have other information, for example, the number of plants that are located in each province, but we do not actually have this kind of information on the way waste management is actually delivered. There are, I know that there is a collection of further data which is provided by or collected, and which has to be provided to the chambers of commerce, but this data is not publicly available.
Right.
We could use this data because it was publicly available.
Right.
Yes.
Right. Thank you, Leo. I don't know whether the hand close to Andrea Molocchi is an old hand or is a new hand. Andrea, do you have another question? Or is it your previous question?
Excuse me, it's an old hand.
It's an old question. Right. I do have a curiosity, Leo, about the paper. So you actually conclude, as you show among the conclusions, that say the geographical proximity between and among the municipality is actually not the main driver of the community that you do observe, right? And I think that it should be very interesting to find out other kind of proximity different from spatial ones could actually explain the kind of communities that you have. You might be familiar with the famous distinction of proximity made by Moshma into institutional proximity, cognitive proximity. So you have a family of proximity issue. I'm wondering whether you plan to investigate the role of one of these proximity in explaining why the communities are forming that way. Any idea
Well, yes. I mean, actually, what we had in mind at the beginning was just to see whether the network complex approach, the complex network approach, could be used in some way to this field, the waste management field. And then we had this data from the Ministry of Economics, and then we said, okay, let's try and see as a first step what we can get. In this case, but obviously, if we had the chance and the data to expand this, that would be very interesting. For example, with maybe say even some cultural aspects, which seem to be very important in the attitude towards waste management.
I mean, at the municipality level, frankly speaking, I would start with some sort of institutional proximity. I think that at that level of analysis, you might find out some proxy about the quality of institutions at that level, and see whether, you know, difference of similarities in terms of institutions could explain why two distant geographical municipalities are in the same community, for example. That could be an idea. But I think that you can do a lot of interesting work using that data. It's very interesting.
Thank you very much. Thank you.
Right. Any other questions from the floor? No? Okay, so we don't have other questions, Leo. Thank you for your presentation. So we now move to the third paper, whose presenter is Anna.
Hello, can you hear me?
Oh no, Sara.
Yeah, it's Sara and Luca.
Oh, you're gonna present both of you?
Yeah, we sent an email to Professor Dotti a few days ago, explaining that Anna will not join today.
I didn't got that message, but it doesn't matter. I know it now.
Okay.
Yeah.
Go ahead.
That was actually a mistake of mine, Sandro.
Don't worry.
But I just took it easy and I said yes, it's possible.
Yeah, you did well. Go ahead.
Okay, thanks. I will share my screen.
Yes, please. 20 minutes time, 5 minutes remaining, I will alert you.
Okay, can you see my screen?
Not yet.
I saw it for a moment, now not anymore.
Okay, wait.
Try it again. It's like it's trying to, but then it stops.
Okay, I'll try again. Sorry, because I don't use very often Google Meet.
It should ask you whether you want to share.
Now it's presenting.
Yeah, good. Now we have it.
Okay. Okay. So thank you for this opportunity. My name is Sara Ratti, and my colleague is Luca Macari. We work at the Politecnico di Milano, and today we will present the advancement of Renetta research project. Renetta stands for Remanufacturing Networks for Tertiary Architectures. The general aim of our research that lasts for 2 years is the definition of organizational and operative business models for the activation of regenerative circular processes based on remanufacturing and reuse strategies related to tertiary buildings that are characterized by short-term cycles and frequent renewal interventions. So to briefly define the scope of our research, so I said that we focus on the tertiary buildings that are that could be suitable for the startup of remanufacturing and reuse processes because of some characterizations of their nature. First of all, the high frequency of the renewal interventions, the presence of an accelerated obsolescence of the equipment fittings, and the prevalence of the components that are mainly dry assembled and with high performances. But where are the tertiary buildings destinated in the world? Tertiary buildings assets include the real estate units used in the offices. So we mainly refer to the office units, to the buildings that are used for exhibition activities, so events and fairs, but also to the retail sector. So meaning that we refer also to the shops. So the units, the real estate units used for shops. At geographical level, the research is focused mainly at the Lombardy region level. And this is because the Lombardy region emerges at the national level as a really significant place for a scenario of tertiary buildings, since it has a very high amount of tertiary building stocks, and also think about the development and the impact of the exhibition activities in the main in Milan municipality. Unfortunately, not this year, but Milano Fiere is a very important standpoint for exhibitions at the national level, but also for trends that are emerging now, especially in Milano municipality, that takes the buildings more and more as a temporary asset. Think about the co-working and hoteling and space sharing activities that are emerging more and more in big cities. So to mainly summarize the project aims that are to reduce the waste deriving from tertiary sector, maintaining the economic value of the building components through the promotion of some circular processes and practices that are the remanufacturing and reuse. We mainly want to improve the competitiveness of the stakeholders that are the players of some relevant supply chains in the economic environment of the Lombardy through the transfer of new organizational and business models based on remanufacturing and reuse. And this could support also the opportunity for new jobs and the development of professional skills. So the nature of this project that is based on different areas of studies implied the multidisciplinary nature of a team. So mainly the Renetta project involves 3 different departments of Politecnico di Milano, mainly from the technology of architecture and building construction, the design for sustainability, and the management engineering area. So this is a snapshot of our team that is composed by 14 people, both that are professors, senior or junior researchers. So I don't want to waste time to present some advancement of the analysis. So I will start from the first step of the analysis of the research that mainly involves the analysis of the terminology. The first objective was to find if there was a clear definition of and generally accepted for remanufacturing. And this was done through the intensive literature review of the scientific state of art, but also a review of the international regulatory references that are here reported. Through this analysis, there was mainly the object was not just the remanufacturing practices, so remanufacturing activities, but also other let's say circular activities that we defined as reactions. So those actions that are typically referred and associated also to remanufacturing practices. This was one of the findings that that emerged from this terminology analysis. So, and we refer to those practices such as repair, refurbish, reconditioning, that in some ways were attached to the concept of remanufacturing. So the analysis included also these definitions, these terminologies. The analysis was done through the different lenses, distinguishes 5 different, let's say, criteria. So the function and the purpose of the original product compared to the final product. So if the function changed after the reprocessing, the circular activities done on the original element. Second, the quality and the performance that could be tested on the final product with respect to the original product. So if the quality is superior or inferior or as before the original product. Third, if there was any warranty on the final product, so after the circular activities, circular process on the product, if there was a warranty on the final product or not. Fourth, the object of the reaction that could be done, that could be actually the at different levels, so at material level, component, or at the entire product. And fifth, the phase at which the circular process should carried out. So if it was at the end of life or at the residual useful life, and so on. So the main findings that are that emerged from this first terminology analysis, that there was not a globally accepted definition of remanufacturing, both in the scientific literature and from the international regulatory standards. So implying that there was a multiplicity of actions, of circular processes that were associated to the concept of remanufacturing. And this was valid both at cross-sector, so in multiple sectors, and of course also in the construction sector that is our focus on the research. So after the terminology analysis, we performed analysis of the existing case studies in the literature, analyzing the experiences in remanufacturing in a cross-sector environment. So we identified 74 case studies retrieved from 13 business sectors. And as you can see from the table, the most relevant and the most established realities in remanufacturing are retrieved in automotive or electrical and electronic equipment and machinery sectors. Constructions, as other sectors, reveal a few experiences in remanufacturing that have been already studied in the scientific literature. So the case study analysis showed that the sectors with the greatest chance of successful implementation of remanufacturing have some key characteristics. First is the economic value of the materials used and that compose the product, that enable also the opportunity for of remanufacturing and reprocessing. Second is the maturity of the technological cycle. Third is the availability and so also the cost effectiveness of the technology that enable the reprocessing. And fourth, also the potential of an offer as a service of the product that could be reprocessed. So the way the product is offered to the market, offered to the public, to the audience, if there's a high potential of offering this product as a service, this could be a lever for remanufacturing opportunities. Second, the second main thing that emerged from the case studies after this analysis is the definition of some key elements that are we identified as enablers and key elements of organizational models that are based on the remanufacturing. And these are the elements that are listed in the table, so that are mainly related to the design of the original product, but also on the reaction. So we use again the term reaction product design, but also the strategy for the procurement of the product, the collection that is refers to the physical collection, so the logistics actors and dynamics that can enable remanufacturing activities, the actor that performed that remanufacturing activities, and their distribution. So after the processing, the distribution of the reworked product, the concept of ownership. So who owns the product and how the ownership is transferred, and well, whether the ownership is transferred along the flow of the product during the whole remanufacturing path, the revenue configuration, and the market destination and segment. So we're referring here to whether the market destination could be different or the same as the market destination of the original product. So briefly here on the right, we listed the possible configurations that have been retrieved from the literature and the analysis of case studies that are linked to these key features that, according to our analysis, are those that characterize the organizational models based on remanufacturing.
You still have 5 minutes to go, huh?
Okay, I will leave the word to Luca.
Yeah, thank you, Sarah. So yeah, we understood the key feature of organizational models based on remanufacturing. Then we had to move toward the construction sector, so understanding how these models can be applied to the construction sector. We started talking with stakeholders, so manufacturer, providers, or even clients from different sectors within the tertiary building area, and mainly, in particular, the exhibition, retail, and office. And how we did that, we organized several roundtables aimed at share knowledge and learnings with stakeholders on the topic of circularity and obviously remanufacturing in this sector, aimed at obviously designing new innovative and circular models. We followed 3 steps, so evaluating, analyzing current business models in the construction sector, highlight some innovative approaches and their potential for innovation, and finally proposing the new circular business model based on this strategy. Okay, go on. As regards the basic process, it's just, let's say, we summarize in this basic process, which is linear and usually ends with the landfill disposal, or at most the recycling. So next slide. We try to understand which opportunities are in this linear current business model that could lead to the implication of remanufacturing strategy and activate circular business models. Go on. So here, trying to understand opportunities in this current business model, we try to identify 3 different innovation approaches. The first one can be summarized in the word disown ownership, in which the client is not owning the product anymore, and the ownership is retained by the provider, which is offering the product with some contractual options like rent, leasing, based on the performance. So, for example, pay per use or pay per period. And this is the base for the first model I'm going to present. Then the second innovation approach that we analyzed is from product to product service. So in this case, we are talking about selling, but selling a product with all-inclusive services that are aimed at extending the useful life of the product. And this is at the base of the second model, which is all-inclusive service as support for remanufacturing. The third innovative approach that we investigated is, let's say, from linear single sector model to circular cross-sectorial models. And in other words, we can say, summarize this in retrieving products from a market and thanks to remanufacturing, or better in this case, repurposing, making them opportunities for new markets. And this is the base for the third model. In describing the models, we adopted some key elements. We tried to represent some key elements, so the actors involved, the flows, so the relationships between the actors involved, material flows, so how products are moving and how the financial relationship are established, the ownership of products, and the contractual relationship between the provider and the user. So I go directly to the first business model, which is a model in which the provider is renting products, which are co-manufacturers, and the same manufacturers are responsible for carrying out the remanufacturing activity at the end of the value chain. So key actors are, as I said, the manufacturer and the provider, which are collaborating in a strict partnership because they are both interested in designing products that are facilitating the remanufacturing at the end, but since it's, as we said, in charge of the manufacturer itself, but also that design products that are long-lasting, because since they are offered with rent contracts, it makes economically interesting if they are lasting more and more. So let's say that the economic advantages in this way are going in parallel with circular strategies. Next model. Oh, sorry, next slide. Yeah, I go a bit faster on barriers and opportunities, but in general, we can say that in this model...
You get 2 minutes more, 2 minutes.
2 minutes more, okay. I think we can maybe make it, but in general, in this model, barriers are the most maybe is that clients are still stick maybe to traditional way of purchasing products. So they claim the ownership and that the rent contract are usually made for a short-term solution, while big opportunities are that rent solution are already established in some parts of the tertiary sector, so for repair setups and temporary installations, and the great opportunities of opportunity of design for remanufacturing, which can solve a lot of problem at the early stage of the design process. That's okay. Obviously, let's go to the next slide. Okay. So second model is the all-inclusive services support for remanufacturing. As I said, in this case, the provider, which could be, for example, a contractor, is selling the product, but it's including services for extending the useful life. In these services is included also remanufacturing, which is outsourced to a technical partner, which is a remanufacturer. Even in this case, a key element is the design, because the provider is interested, the provider and the remanufacturer that are working in partnership are interested in reducing the cost for providing the services and making manufacturing easy. But also they're interested in designing for remanufacturing because the product at the end of the first use cycle maybe could be retrieved by the provider itself and maybe sold for another customer. And here the main barrier is for sure the customization, because in case you are customizing too much a product, then it's quite difficult to sell it to another customer or to apply remanufacturing processes. While opportunities in this case are obviously technical partnership with a specific remanufacturing, and again, design for remanufacturing, which we understand is a crucial element for enabling remanufacturing. I will go to the last model. This model is the remanufacturing as an independent activity in which the remanufacturer is products. I'm going to conclude. The remanufacturer is retrieving products from a first use. So let's say could be the office market, for example, and it's working really close to, in partnership with a commercial actor that could be, again, a contractor, and they're interested in redesigning and remanufacturing the product that is retrieved from a first market toward a new product that is an opportunity for a secondary, not secondary, but an alternative market. Key actors are the remanufacturer and so can you go back? Sorry, I want to conclude on that. And the contractor, key important is the contractor, because in this case, products are redesigned to be, again, remanufactured. So even in this case, the contractor is interested in offering with a contract solution in which it's okay a sale, but the ownership is retrieved through a deposit mechanism. And in this case, the customer himself is interested in giving back the product for another process of remanufacturing, which is, again, programmed, let's say, took in consideration at the design phase. So it's convenient and activating circular business model. Yeah, I think we can maybe conclude here. In general, another barrier is that the many different actors, or maybe better than a barrier is a need, that single actors need to go toward cross-sectorial knowledge, because we saw in the models that providers are maybe doing in some cases, also providing services and are also collecting products for use. So they need to have expertise also in logistics. So there is a need that goes transversal with the three models, and I guess we are done. Thank you for the attention. And if there are questions, we are open to answer. And I'm pasting our link for in case there are further questions for the coffee break afterward. I'm putting in the chat.
Thank you very much, Sara and Luca, and sorry me for being so pressing with time, but unfortunately we have time to respect. Now, I don't know whether there are questions from the floor. Let me see in the chat if there's something. It doesn't seem to be there. Any questions from the floor? No? I might have a couple of questions, which are whether sort of methodological kind of questions. I've done some work on business model for the circular economy, but using different, say, kind of methodology. So more looking for more systematic evidence rather than case-based, right? But this is extremely helpful, as an initial step for more systematic evidence. So the first question that I have is, how did you look for the relevant case studies that you distributed among the different sectors? Because I was somehow surprised finding some sectors more represented than others. So I'm afraid that has to do with the way in which you look for those case studies. And I'm wondering if you can briefly report about that, okay? Second question is about the three kinds of business models that you have identified, whether you have made an effort to plug these three business models among the categories of already identified business models. For example, there's this distinction between circular innovation, circular input, and circular output models. You can have galleries of classification. I'm wondering whether you have made an effort to plug your three models into one of these already existing categories. That could be an interesting exercise to do. Please be brief in your reply.
Okay, I will try to reply to the first question. Okay, so mainly the case study analysis has been done for starting from this main source that has been retrieved from a comprehensive analysis of the case studies that could have been researched and studied from the existing literature. And as we said, we tried to briefly say that there are some business sectors where the remanufacturing experience is an established reality. And also the disclosure and the availability of data and information could have been more deeply, let's say, studied in the literature. In this preliminary case study analysis, our source was the existing literature. So what we have done, it was not to further, let's say, analyze existing case study in Lombardy or in Italy, but was like, let's say, a cross-sector literature analysis.
That is what emerged from the literature, you said.
Yeah,
okay.
Exactly. So also the shares that, well, what is representative from this analysis, of course, it's not representative of like the comprehensive set of business sectors, as you said, and that's right. But what we actually try to extract from this analysis was the main organizational elements of these case studies that were not strictly necessarily linked to one business sector, but these were some elements that were analyzed and retrieved from a complete study of different business sectors, so not strictly related to the specificity of the sector.
Okay.
Yeah, about the second question, so plugging with existing and let's say maybe working business models in a specific sector, we, let's say, worked in coherence with the previous part of the research. So the outcome of that case study analysis and literature analysis was the definition of key features that are defining some working business model based on remanufacturing in other sector, but in the specific sector of analysis was highlighted the lack of existing working models and examples to, let's say, to plug or to, let's say, take reference from. So that was the first efforts, working in coherence with what was working in other sector, but the effort made with stakeholders was to obviously bring that, let's say, that work of assumption into reality as a first explorative step. Then obviously there will be needed a further, let's say, systematic work in how to say, maybe working more in abstracting after this very practical confrontation with the industry, in abstracting again, taking reference from what has been already studied. So trying to understand if what the industry told us may fit, may match with other models. But the base is that in the specific sector we are analyzing, there is a lack of this business model based on circularity. In any case, always a look has been given on what is existing. For example, in trying to make our assumption, obviously there was a reference to maybe some mechanisms that are already applied in sustainable product service system models, and yeah, some these that are already existing in the literature. But maybe first we needed to check with the industry and stakeholders.
Yeah, and I don't know whether it's part of the project, but I personally suggested that I have a researcher that, in addition to identifying obstacles and barriers to each and every model, if you can try to suggest or spot some proxies for detecting those business models on a more systematic basis, that would definitely be very helpful for further research, right? So if you would be able for each and every kind of model to say, this is a set of indicators that we could use to identify this model. This is a set of indicators for the second model. This is a set of indicators for the fourth model, right? That would be very helpful, because my personal experience is that we have a lot of case-based evidence on business model for circular economy, but when you go to systematic work, it's really a mess. And I think that that further work on indicators, given that you are this fantastic project, which is very nice in terms of interdisciplinarity, if you could pay certain attention to the approximation and measurability of a business model, that would be very important. Sure. Right. Thank you very much. Thank you to you guys. Okay, now it's time to move to paper number 3, whose presenter is Erika. No? Yeah?
Yes.
Yes. Erika is, yeah, okay. Erika. So please go ahead with the third paper. The floor is yours.
Okay. Thank you, and good evening to everyone. I want to thank the church's staff for everything, particularly Jacopo Zotti and Fabio Eboli for the support, for the emailing activity and everything. So in the meantime, I try to share my presentation, and okay, let me know if it's okay. Can you see my screen?
Sorry, not yet, Erika, not yet. We don't see it.
Oh.
We can see yourself trying to share it, but not the share.
Okay, now?
Not yet. Oh yeah, now it's starting presenting. Yeah. Yes.
Okay.
You can put it full screen if you want.
Okay, I am full screen. I am seeing the full screen. Can you see?
Okay, go ahead. Yeah,
okay.
We can see it. Go ahead.
So thank you for this opportunity, and I present this contribution on an industrial symbiosis case study in Umbria region as a successful cooperative approach of circular economy. These are an outcome of a big job from a large working group, and I want to also thank all my colleagues. So basically, I can start with some definition of industrial symbiosis. One of the most classical industrial symbiosis definition affirms that industrial symbiosis engages traditionally separate industries in a collective approach to competitive advantage involving physical exchange of materials, but also energy, water, and byproducts. So anyway, a local or a wider cooperation in an industrial symbiosis can reduce the need for virgin raw material and waste disposal. Thereby, it can also reduce emission and energy use by creating new revenue streams. In addition, an industrial symbiosis approach can also implement a closing material loop strategies, and this is a fundamental feature of a circular economy. Circular economy, as we know, represents a radical paradigm shift from the linear economy models, and also supports the development of new sustainable business model with the final aim to increase both the potential for closed loop productive system and also the resource efficiency in a territory. Okay.
Erika, sorry if I bother you, but I can still see the first slide. Did you change and move to following slides? Because I just see the title. Okay, now it moves. Yeah, now I can see that on benefits, but I don't know whether you are one slide ahead or.
Oh, it's strange. I can see everything. I mean, every slide.
Now we can see industrial symbiosis benefits. Okay, now you are at slide number 3, just now.
Okay, but now that's okay?
Yeah.
Okay, so an industrial symbiosis approach can lead to some advantage in terms of economic benefit, for example, for cost reduction for raw materials and energy and for landfill disposal, but also to create a new business network and new market opportunities. In terms of environmental benefit, an industrial symbiosis can lead to an optimization of the use of resources, mitigation of pressure of environmental and emission, and landfill disposal avoided. In terms of social benefit, industrial symbiosis can lead in an employment of the green jobs, the so-called green jobs. For example, given that an industrial symbiosis is a complex approach in which many actors can have many parts, became really important the role of new professional figures in this aspect, in these fields. For example, industrial symbiosis facilitator, because industrial symbiosis have to be facilitated and supported by many actors for a successful approach. So the European level, an industrial symbiosis.
You should move the slide on. We still have slide number 3.
Always this problem. I don't know why.
Yeah, because you should go in the full screen mode and then use page up or page down. But if you remain in this mode, you should use the column on the left hand side. So with the click of a mouse, move 4 or 5 like you are doing now. Okay.
Probably with this. Okay. And okay, it's better now.
We don't see the full screen mode.
Oh my God!
But anyhow, you can move ahead.
If I leave this way, it's better. Okay, so I go in this way. So industrial symbiosis is definitely included in all the programming European document, in many communication from since the 2011 for the roadmap to resource efficiency Europe. And industrial symbiosis was indicated as a useful strategy to stimulate more efficient production through a better use of raw material and the reuse of waste and byproducts. So during this period, in 10 years, basically, the industrial symbiosis is always associated to resource efficiency strategies, but also become really essential for the transition to a circular economy. Until the recent communication, a new circular economy action plan for a cleaner and more competitive Europe, we have the industrial symbiosis as a strategy to be developed in a system of industry-led reporting, but also for a certification system. So in this case, we have a process really including this kind of topic. An industrial symbiosis approach can be generated from different models. So we have a district of industrial symbiosis, for example, for instance, in the experience such as the Kalundborg district. So we have in this case an extensive territorial areas in which many companies are involved in a specific agreement, in specific willingness to participate. This is usually a bottom-up approach in which, without specific programming, the company decided to share results and to have a competitive advantage. An eco-industrial parks is a top-down approach in which is needed to plan an industrial symbiosis pathway, to have to design and management all the synergy on the basis of the industrial ecology. In this case, we have some experience in the Italian level with the ecologically equipped industrial areas, specifically introduced by the Bassanini decree. And then we have the network for industrial symbiosis based on the meeting, just in the easier formula in which the output resource from a company can become an input resource for another company. So in this case, we have a network of industrial symbiosis in which we have the involvement of company that otherwise they have no opportunity to meet. And this approach includes example like the NISP, the British program for industrial symbiosis, but also the Enea methodology at the regional level. In this direction, the Enea developed a specific methodological approach to put into the practice an industrial symbiosis pathway. So I can just list the main phases. So in which in a preparatory step, we analyze all the territory and in order to identify the areas in which to focus our attention. Then we have to map all the IT sector, and we have to study all the productive tissue of the region, the area. Usually we listed and we made a database of 2,000 of companies. Then we have to spend a lot time of networking and promoting of this kind of topic, like an industrial symbiosis, and then we have to organize the workshop. The workshop are the crucial moment of this methodology in which the companies can share their resources in terms of input, output resource by filling it a specific data collection sheet. And in this phase, we have first data processing in which we can try to make some potential synergy, and then from a potential synergy until the effective industrial symbiosis pathway can pass a really long time, and then we have to process the other information. Also about the consultation moment. In the conclusive phase, we have a moment of consultation during which we introduce the first draft of operative handbooks to the institutional stakeholder, local entity, association of categories, with a really constructive moment. Then we have to make a revision of the handbooks, very rich of all the consultation moment. And finally, we deliver the handbooks to the company. The handbook are a very operative tool for the company because they guide step by step the company to implement into the practice industrial symbiosis pathway. Enea developed industrial symbiosis other tools, very useful for company. As I have already mentioned, the methodology, but we have also a platform, an industrial symbiosis platform, a web tool, really useful because it provides for the matching between supply and demand of resources. Then we developed many projects in 10 years approximately, and the projects are really useful because we can test and validate our tools, our methodology. And finally, the network. The SUN is the Italian network for industrial symbiosis, and powers and promotes the systematic application of this kind of approach. So I reported some case studies for an implementation of industrial symbiosis in the Umbria region. We developed two important regional projects, one in 2017, industrial symbiosis in Umbria, and another proper Umbria the year after. Both the projects are financed by the structural European funds with the collaboration, fundamental collaboration with Sviluppo Umbria. Sviluppo Umbria is the regional agency for Umbria's competitiveness and economic growth. And so basically during this first project, we held two important workshops, one in Termini and one in Assisi, really beautiful place. And during this workshop, we invited something like 50 companies to the workshop. We shared something like 300 of resource in terms of input output, and we identified 200 about of potential synergy. So the workshop are really interesting moment of resource sharing, but also many interesting information with the company. And about all this information, we usually have to select the main flow, the main waste stream in which focused our attention. So by following specific criteria, like an analysis of territory, but also by following some indication of the regional agency, and also very strong, very important is the criteria of willingness to participate, because we really need a strong collaboration with the companies to reach an industrial symbiosis pathway. So by following all these criteria, we can select the flow in which focused our attention. In this project, we carried out two handbooks, one for the valorization of waste from olive oil production, and an handbook for valorization of waste from agro-industrial sector. So for the valorization,
you still have 5 minutes, Erika. 5 minutes to go.
Okay, I go fast. Okay, sorry. For the valorization waste from olive production, we involved 4 oil mill in the Umbria region. Actually 3 oil mill and 1 chemical industry. We identify the distance among the involved companies. We give alphanumeric code also for privacy and copyright reason to the involved companies, and we can make a synergy scheme and layout very simple in which we can summarize the synergy. So on the left we have the company that can give the resource in a specific case where the olive mill wastewater, and to another company available to receive this kind of waste. And in this case, so we have this synergy really interesting, because this company, the U015, is a chemical industry really able to transform this kind of waste. So just to make some economic assessment, we reported the cost for the olive mill wastewater in a disposal destination for landfill, and in a scenarios actually BAU, so basically as usual scenario, but we proposed an industrial symbiosis scenario with a new player, the U015. This company was really available to receive all the quantity of olive mill wastewater. They are able to transform this wastewater. For them, this became an important raw materials. In fact, in a chemical process, they can transform this olive mill water in an important product for the cosmetic industry in a final product. So basically, the olive mill water are very rich of chemical substances, nutrients as well. So they can extract, in this case, the polyphenols, really useful for a specific cream, cosmetic cream, really rich of anti-aging and antioxidant effect. So they can sell this final product online. They have a really good online commerce of this product. This is the company Poly4Life. They register a patent, a specific patent for these new technologies, and they find really interesting our project. But in any case, we propose to the company other destination of this product, because this product can be also used in a pharmaceutical sector to produce medication, but also in the food sector for the food supplements in the specific case. And we also indicated the ADECO code for potential destination. And the other case studies, a successful case study, it was the proper project, also we in the Umbria territory, and with the Sviluppo Umbria as well, with the strong collaboration of Meccanotecnica Umbria. We reach fundamentally two goals. So we made a resource audit as an internal evaluation to make more efficient their production process, but also an industrial symbiosis as an external choice to valorize waste. So Proprio Umbria also in this case were really interesting project with this company. They produce basically, they work in the mechanical sector. Is an important multinational company. They produce mechanical seals. So a group of coil rings practically for standard duties, but it is very useful for other destination sector of destination, like automotive, but also household appliance. Basically, in every sector in which there is a mechanical engine, so it's very widespread. So we analyzed all the production process very in deep, and we identified two output to valorize basically in this production, in this layout of process. Basically, they mix the powder of coal powder, phenolic resin, and graphite to make these coil rings. And they have the critical waste of this mixed powder in the upstream of the productive process, but also they have many sludge, industrial sludge to treat. So
you should try to come to a conclusion because your time is over.
Okay, so we proposed scenarios of valorization, and we usually analyze our outcome in terms of LCA, in which we can show the environmental benefit of this kind of analysis by comparison to scenarios. And usually with this kind of valorization, we can have important reduction in terms of different categories of impact. So usually in LCA study, we have the category of impact like acidification, climate change, particulate matter, and in the industrial symbiosis scenarios, we can have important reduction. With the red histogram, we can see important reduction of environmental impact. For example, we have the 22% for the category of acidification for these valorization scenarios, but also the 33% for the category of climate change, and 86% for the category of exhaustion of mineral and fossil resources. In other words, we have better, best performance in terms of environmental benefits. The studies are very specific. I reported some references if you want more information about, and I can conclude my presentation just to make a special thanks to the company that can make a successful case study, the Poly4Life and Meccanotecnica Umbria. I really thank you for your time. I'm sorry for my speed, for my speech, and probably to Harry. And I'm available to discussion, comments, questions, and so on. Thank you.
Thank you, Erika. Thank you very much. And apologies for myself in turn for having been so pressing in terms of time. But, you know, we need to conclude. It's 6:30. Any questions from the floor? Curiosity, comments, clarification questions? Let me check if there's something in the chat. Nothing from the chat. So I could start myself. This is very interesting kind of activity, very important. I do believe that symbiosis, industrial symbiosis, is one of the key pillars of the move towards the circular economy, and therefore mapping and favoring experiences like this is extremely important. The question that I have is a question related to my data needs as a researcher. as far as understood, you do have a sort of database of these case studies. Is it correct?
Yes, it's correct.
And I have two questions. First question, if you can tell us how distributed these case studies of industrial symbiosis are across the territory, if they follow a certain geography, if they are more in the north, less in the south, if there's a geography of these cases of industrial symbiosis. And the second question is whether the database that you have of these case studies is available to researchers, if it contains data that the researchers can use, for example, in terms of number of firms that participate to each and every industrial symbiosis case, the kind of flows that you have mapped. I mean, which kind of info do you have, or do you render accessible to scholars like myself, for example?
Okay, I start to reply in the second question. So the database are not open. I mean, if you want to participate to the database and to also to have access to this kind of information, you have to register on the Industrial Symbiosis website on our platform, specific platform. In this case, you can share all information about the basically about the production and the production process. So I mean, we request every data about input or potential output of your production, for example, and then depends on different level of permission. You can also see the other results if you are available to share your information. I mean, with different level of freedom, you can go. You can find different information inside the platform, and in the platform you can find also not also the database, but also the other case study and the best practice already identified and very realistic case, and also every information about the database of inventory of material and categories of impact for the environmental analysis, for example, also the LCA database in this case. And so this is the level of freedom that you can share the information. For the other question, so surely the industrial symbiosis approach depends strongly from the geographical proximity. So usually the projects are really moved on this kind of interest from the companies and territorial area specific, for example, like the Umbria region, and usually have to be financed, or at least have to be it is necessary to find an interest for a project, for a specific financed, hopefully, project.
Okay, thank you very much for your reply. I don't know whether in the meantime other questions have appeared. It doesn't seem so.
Yes.
Oh, there's a question.
I'm Andrea Molocchi.
Andrea, go ahead.
Good afternoon, Erika. I'm pleased to listen to your presentation. I was thinking about the so-called Italian Register of Waste that is managed by the Ministry of Environment. This kind of, I don't know much about it, but I know that it exists. It's a long time. The ministry is making an effort to publish this kind of data. Are this kind of data published or not? Are they used? Are they available to be used for symbiosis, industrial symbiosis analysis? Because this could be a very powerful tool in theory.
Yes, in theory, yes. And there is also the register, a list of waste and byproduct Also with the Chamber of Commerce is already published some information about it, but in any case a registration is needed, and after registration you can see some information about the data, about the waste, because they are really sensitive data, so they are really protected. So actually I don't know the exactly level of publication of this kind of information, but in any case exists the register, you're right, also not also for the environmental ministry, but also for the there is the register of the byproduct for each chamber of commerce for a regional level. So each region has a register like this, but actually I don't know exactly the information and the data and how they can be shared.
Right. Okay. Thank you very much for your reply, and thank you to Andrea for his question. I think that now it's time to close because there's.
Can I just ask something more?
Oh yeah, yeah. Please, I didn't see your.
Yeah, sorry.
Please go ahead.
Okay. Can you see me?
Yes, we can.
Yeah, I just want to ask that is the handbook that you have developed, does it can I use it for different sectors, or is it general, or is it very specific for some sectors?
It's very specific. Is a very document really important and really specific for sector, for every waste stream analyzed. I had no time to explain well this aspect, but the handbook are really also very covered by copyright. We don't share this kind of information because it's a deliverable for the companies really involved in the project. Usually in this handbook we go in deep every legislative aspect, the standard, the specification for sector, and every compliance for administrative aspect. So it's very specific, and each time we work really much on this, and we go in deep every aspect of the synergy that we designed.
Okay, thank you very much.
Okay, I'm afraid that I should conclude. So I've seen that there's sort of virtual aperitif. I don't know, Jacopo, what are going to serve? A virtual spritz or virtual wine? I don't know what's going to happen now.
Yeah. Well, actually, Sandro, I would suggest you not to dream too far away. Well, you know, these should be just a quite short time slot for presenters to receive further questions or to have, let's say, a further interaction opportunity. In fact, I saw in the chat that two of them, say Ximena and Luca, posted a Meet link. So which means that if other participants want to get in touch with them, they can approach them, let's say until 7 o'clock, because I think then the aperitif will be over, and the second workshop day will be also over. So that's it about this virtual aperitif.
Okay, you disappointed me, but okay.
I know.
Jacopo, I have to excuse, but I have to move to another webinar now. So I simply said goodbye to everybody. It has been a very interesting session. I listened to a lot of interesting things. I've learned a lot, and I really thank you for that. I wish you all the best for your future work and research. And I say you bye. Jacopo, I'm sorry, but I can't stay any longer. So if you want to get back, so if you're going to get back with me, we can hear each other in the next days. Okay? Bye-bye, guys.
Of course.
Ciao.
Bye.
Ciao.
Ciao, thank you. Goodbye.
Bye, Sandro. Thank you very much.
Bye-bye.
So I would leave the floor then to this, let's say, aperitif session. And I will just wish you a nice evening and see you tomorrow at 9:30 with our third keynote lecture. Bye-bye.
Bye.
Goodbye.
Thank you, Jacopo.
Bye-bye,
Thank you.
Hi, thank you.
Bye-bye. Thanks.
Bye-bye.
Bye.
Bye. Ciao Fabio.
Ciao caro, adesso mi tocca parlare con un tesista, vabbè. Continua la serata. Stammi bene, ciao caro.
Grazie, ciao, grazie.